Our next session, here on the Divisadero stage, will begin in 10 minutes. Please find your seats. MongoDB CTO Jim Scharf will take the stage in 5 minutes. Please find your seats. Our next session, Decisions That Will Define the AI Era, is about to begin. Please take your seats and silence your phones. Welcome back, San Francisco. Now, please put your hands together for MongoDB CTO Jim Scharf.
Hello, I'm Jim Scharf, CTO of MongoDB. I'd like to take a few moments to welcome you to the MongoDB Build Fest. I hope you're having a great day so far, because we have an exciting agenda for this afternoon as well. Well, you've likely heard many people opine about the future of AI. My father cites a famous quote: "Those who do not learn from history are doomed to repeat it." I find it a little ironic that he's repeated that phrase to me probably hundreds of times over the years. So before we look to the future, I thought I'd take a moment to see how the past may guide us. As the token graybeard on the stage, I thought I'd reflect back on a recent tech innovation that transformed our industry: cloud computing. Before MongoDB, I was lucky enough to join Amazon Web Services back in 2004, long before its first launch. I spent 17 years as a general manager and builder of some very critical services, including identity access management and key management service, among others. And while these services unlocked the cloud journey for countless companies, these did unlock for countless companies, I also got to work closely with C-level executives at many companies, helping them navigate their transformations as they moved onto the cloud. From that experience, I see many parallels between the cloud journey and what we're now seeing with AI. To start off, I saw that many customers, lift and shift seemed to be the easiest path to move to the cloud. They attempted to take their existing application stack and processes and simply move them onto someone else's infrastructure. They didn't change their applications much, just where they ran. This seemed like the easiest path. However, over time, these customers would later come back and report that they didn't see the big business impact of moving to the cloud. Conversely, other customers chose to embrace the new technology and re-architected their applications to take full advantage of the cloud. These are the ones where the move had the greatest business impact. Customers such as Netflix, Airbnb, Twilio, they built natively on the cloud, disrupted whole industries, and built durable businesses that live on today. Now, I believe we can see the same pattern playing out in AI today. Many companies are attempting to just apply AI tooling to existing teams, data, and processes, hoping to see big business impact. Yet, like the lift and shift folks from the cloud computing era, what they're seeing is mounting costs and meager gains. What I'm finding in my own teams is that AI tooling has the greatest impact when we seek to embrace the new technology and are willing to adapt our team, systems, and processes to take the most advantage of it. That's where we see not just efficiency gains, but AI enabling us to achieve things that we previously thought were impossible. And it's not just teams and processes that need to adapt. The AI application stack itself needs to be different. Your data has to work harder. You are not just storing and querying it, but you're embedding, indexing, and retrieving it in ways you never had to before. For this, you're adding entirely new components to your applications. Components like vector search and embeddings models bring with them new operating security and observability requirements. So just bolting these components onto your current stacks and dealing with the complexity that brings is the equivalent of lift and shift in the cloud world. It might feel like a short-term win, but you need to rethink what you're doing and architect for this moment to have the biggest impact. As people look to define an architecture that embraces AI, customers are telling us that MongoDB has a lot to offer. Most agents default to JSON, and MongoDB made JSON documents a fundamental part of its architecture from the very beginning. JSON documents are ideal for AI velocity because of their flexibility to change and adapt as needs evolve. They map naturally to how applications represent data, and that flexibility matters more than ever as agents need to read, reason over, and write back complex, evolving data structures. Now, I know that many of you probably think of MongoDB as just a document database company, and that's fair. MongoDB is the real-time operational database powering applications for nearly 75% of the Fortune 100. But AI changes what a database needs to be. The nature of AI requires new application components to power advanced forms of search, ensuring you retrieve the right information in the right context at the right time. This is much more than just an LLM. You need vector search, hybrid search, embedded models, and re-rankers. That's why we've natively integrated these technologies directly into MongoDB. That's the difference between adding AI to your stack and architecting for it. Now, another reflection on cloud computing that may guide us in our AI journey is security. When Amazon Web Services first launched, almost all enterprise companies told us security was the primary reason they would never adopt the cloud. However, over time, the cloud providers added identity and access control, encryption key management, audit logging, and a wide range of other security and governance features. What was amazing is that in just a few years, some of those same companies shifted their stance. They realized that security actually became a reason to adopt the cloud. Among other reasons, the ability to regularly spin up and tear down their cloud environment was a powerful new way to limit security exposure. Now, I see a parallel here when we look at AI. We see some of the very same tensions in the industry. On one hand, my security teams are moving extremely fast to implement the tools, observability, and procedures to ensure that every MongoDB employee who builds an agent does so securely. At the same time, that same security team is first in line and is consuming the most tokens and the most expensive tokens using AI tooling for good to detect and remediate potential security vulnerabilities in the software we build and procure from our supply chain. Now, pretty much every CISO I talk to describes the same tension. Most recognize that AI has completely transformed the security playing field. Many talk to me about the struggle their security and engineering teams are facing just to keep up with applying all the security patches coming from their software supply chain. As just one example, Microsoft, who has honed their security practices over decades, in July had their biggest Patch Tuesday ever, with over 500 CVEs and 3 0 days. Today's reality means that we all must radically drive down the time to patch our software and systems. It's what is required to stay secure. That's exactly where the value of a managed service like MongoDB Atlas shows up. We have over 60,000 customers using MongoDB, and we are responsible for the patching, so you don't have to. We've invested in the automation to reliably patch hundreds of thousands of database clusters, all while our customers sleep soundly at night. Bottom line is, the benefit of having MongoDB Atlas engineers helping customers is even more important now in the era of AI. So the next parallel I see between cloud and AI relates to where you run your software. In the early days of the move to the cloud, it became a bit of a contest. Cloud providers would trot out customers out on stage who would proudly announce, we're all in on AWS, or Azure, or Google. The logic was this was a big investment, so CIOs would have to pick a platform and stick with it. But that clean border eroded fast. Mergers and acquisitions, along with regional and geopolitical concerns, have led most customers now to operate across multiple cloud providers. My former employer has acknowledged this reality and allowing their employees to utter a word that was previously forbidden by their marketing department, multi-cloud. We're watching the same thing happen with AI, just faster. New regulations in the EU, like DORA, are shaping where data lives and who manages it. Specialized chips and hardware are scarce enough that nobody can bank on a single supplier. And open weight models mean the question of where your data needs to sit suddenly is back on the table. The whole landscape, chips, models, regulations, et cetera, is changing so rapidly that customers do not want to lock themselves into one path and need to keep their options open. As a result, our customers are telling us that flexibility to run MongoDB anywhere is more important now than ever. They love that Atlas can easily run a MongoDB cluster across AWS, Azure, and Google Cloud, and they can select from over 131 regions. But they value even more the optionality to run MongoDB on premises wherever they may need. Now, I could stop here. I've laid out 3 things that map cleanly to 3 MongoDB advantages. And if our chief marketing officer had her way, this is exactly where I'd just walk off stage and say thank you. But I'm a technologist, I'm a pragmatic, and I try to be a realist. There are plenty of places where the industry hasn't converged on answers yet. And one of the biggest areas is governance. Now, when the cloud first launched, customers didn't have a lot of options to govern its usage. Access control, data protection, observability, limits, usage policies, all were missing. This led to what the industry dubbed shadow IT. At Amazon Web Services, we scrambled to build out capabilities in all of these dimensions, and I was lucky enough to lead teams in these areas. Over time, adding these capabilities really unlocked large enterprises to move to the cloud en masse, and this really unlocked growth for AWS and the other cloud providers. So it's worth asking, where are we now in AI? I can tell you about my own teams. There isn't a week that goes by where we're not talking about how we need to add better governance and controls. And frankly, once we have better governance, it'll likely lead to even faster adoption because we'll feel even more in control. And as I talk to both customers and peers, CTOs and CIOs, it's pretty clear this is something the whole industry is wrestling with. This is the part of the story the industry, including us, is still writing. Now, it's an area where we're investing in heavily, and you'll soon be hearing more from us coming up soon. But here's what I'll say now. The companies that figure out governance early won't be the cautious ones. They'll be the ones unleashed to move the fastest. That was true of the cloud. The enterprises that nailed access control and audit logging didn't slow down. They're the ones who scaled the fastest. So thank you for indulging me on this trip down memory lane. I hope that by looking at the past and using the cloud transformation as a guide, I provided you with some things to think about as you go back to your day jobs and build the future with AI. AI is running and evolving the same patterns, just on fast forward. This is what MongoDB is here to help with. So with that, I want to continue the conversation about the AI era transformation. And there is no one better to talk about that than my next guest from OpenAI. Please join me in welcoming Jason Liu to the stage. Cool. Thanks for, how about this way? All right. Thanks for joining us today. I know you have a very busy schedule. Pretty big crowd here in San Francisco.
This is incredible. Thanks for having me.
Yeah. So can you give everyone a quick intro to your background and your role at OpenAI today?
Yeah, so I'm Jason. I work on the developer experience team. And so my goal is really to help everybody develop on our platform, whether that's using Codex and ChatGPT work to do your job, but also build with the API. Before then, I did my own company, mostly actually helping companies adopt things like retrieval and search. And so I think MongoDB plays a big role in that as well.
Cool. So what are some of the lessons you learned early about building AI products that are most useful to end users?
I mean, I think the biggest thing is really understanding what is the job to be done, right? I think before, maybe 2 years ago, we think of AI as a chatbot. It answers some questions, and then you kind of make a decision based on that answer. Now it's really about delivering work. And so if you can understand what is the work I need to do, if I had an employee that just joined today, what data do they need access to? What are security rules that they have to follow? Once you model that out, generally I think the models are now smart enough to sort of get very close to completing that task.
Yeah. Do you find it requires different roles from you as a builder?
Yeah, I mean, I think a lot of it now is, as long as I can describe what needs to happen, I can have AI build that out for me. But what this actually means in production for me is that I have to just talk to more people now. I need to actually understand what the requirements. I want to build a Slack bot. Well, certain Slack channels are gated by security. How do we model that out? These are sort of the harder things to understand. But once you know how to describe it, you can just go build that out.
Yeah, we're seeing a similar thing in our teams. It's more multidisciplinary thinking, understanding the customer, understanding the business, and understanding the technology as well. So it's a bit of a stretch if, back when you may have spent most of your time writing the code, now you have to spend more time thinking more well-rounded.
Yeah. You get to spend much more time just talking to the users.
Yeah, exactly. So as builders move from prototypes to building production-grade agents, they quickly run into hard systems questions around context, memory, tool use, and state. From your perspective, what separates teams that build compelling demos from teams that build agentic systems that hold up in production?
I would say the first thing is getting the data flywheel running, right? So it's one thing to have a demo, almost like passing a job interview, but the job in real life is much more complicated. And as you deploy this to more users, how do you make sure that the usage or the rollouts are being saved somewhere? If someone complains that the models are not performing well, how do we find those examples and learn from that? How do you build evals? And once you have those evals, as new models come out or as different capabilities come out, then you can start deciding, okay, where do I want to sit on the latency or cost perspective? And I can make those decisions because I've saved those evals from production. If you don't have that flywheel, then it's going to be really hard to just guess what's going on, right?
Yeah, interesting. Do you find your startup experience really helps there in terms of thinking through not just the tech but the business and the performance and all that?
Yeah, I think the biggest one is the common line is you do things that don't scale, and part of it is just looking at the data, looking at the conversations that you're able to look at and understand, okay, what are the personality quirks that the model's having? What are the mistakes or assumptions the model is making, and how can we fix those? And then how do we save those test cases so we can run them in the future?
Cool. All right. When AWS, I was talking about AWS previously. When AI products start getting real usage, what are the first things that usually break or become much harder than teams expected?
I think a lot of it now is going to be around cost management, right? I think before in the demo, you want to use the smartest model because you want to impress someone and make sure the model works. And then as things like cost and latency come into perspective, that's where you have to think about using a portfolio of models, right? So we can go all the way down to the Luna scale models that are very cheap, very reasonable, to all the way up to Sol. And then you can need to now do things like ultra fast, where maybe it's 12 times faster. But you have to understand when does that actually make sense? It's not really the case that you can just sort of run Sol on everything and just get the best performance, because latency matters, right? In the past, in e-commerce, 300 milliseconds of latency could impact your revenue by 2 or 3%. Yep. And we don't really understand what that looks like when it comes to AI usage for the consumer.
Yeah, it's been amazing just seeing how much the pricing, just in the discussion in the industry over the last couple months, how much pricing has been a topic of conversation, and OpenAI even coming out with new models that are much more price performant. So
I think the conversation on ROI is going to be much more important in the coming months.
Yeah. Do you find customers struggle with ROI? Did they have good baseline of measurement before, or?
Yeah, I think it depends on whether or not you can measure what success looks like, right? If it is about data entry and data processing, or if it's about whether or not a ticket is closed, I can look at the cost per ticket closed and understand what the comparables are. But then when it comes to even software development using codecs, those things become much more tricky. Am I just running automations to maximize some leaderboard? A lot of weird incentives there, but for example, me personally, I've actually been using less tokens and getting more work done because I've actually figured out what are the important automations that you're running and how you should think about that.
Yeah, definitely. So from talking to AI builders, they report that challenges often come down to retrieval quality, fresh context, and whether the application can reliably ground itself in operational data. How does OpenAI think about the role of the data layer in making agents accurate, trustworthy, and useful over time?
Yeah, one of the big things that happened with chat early, 2024, 2025, was we introduced web search, right? And that is sort of the first step in minimizing hallucinations, making sure the data is up to date. And that is going to be the same thing when you use something like an agentic harness, right? It's actually the only thing that matters is the reasoning and your ability to find the right data. And now, as agents are much more confident in the ability to sort of make hundreds of tool calls or search thousands of websites, these models are really, really stubborn, right? As long as the data is in there, the model will find it.
Interesting. And how do you see the need in terms of memory and storage evolving as the models are changing over time?
Yeah, because again, like, it is one thing to say, you know what, if I run this job for 45 minutes, I'll be able to find something. And maybe in that world, it's just using grep, right? And maybe this works for many cases, but in many cases where you're interacting with customers, like the latency is the thing that's going to be really important to optimize for, right? And again, with the e-commerce example, like, I can very much easily imagine a world where even a half a second latency can really impact the success of your business and the user experience of your business. And this is where things like search and memory really play a part, because these are the optimizations that will get you there.
Yeah, I think it's interesting as the industry has evolved over the last couple of years, and more agents are getting to production, things like efficiency, pricing, performance, just really real business stuff comes into play, right?
But that's exciting, because if those conversations are happening, it means something is actually measurable.
Exactly. Yeah, no, it's really exciting. So as agents become more autonomous, how has your thinking changed around state management and memory? When should developers persist context versus letting the model reason from scratch?
I think the most part, I would almost always try to persist context, right? Like, we have compaction that can run for like billions of tokens now, and the only thing that's going to allow your model to save this information is to like write that somewhere. And if you're lucky enough to be running it on your own laptop, you can like write to a file system. But there's many systems that this doesn't make sense, right? And so you can virtualize that through something like Mongo, then almost like every agent should have its own namespace and its scratch pad. And then if you have this system running, you can run for like 1 billion tokens or like 10 billion tokens.
Yep.
And that's going to be the future, I think.
Yeah, no, definitely. Even brief aside, but using some of these agents for my own personal life planning and like vacation planning and stuff like that. It'll now be like, oh, well, your wife is into birding, and so while you're on this trip, you should look over there too. And it's just like, wow, and I show my wife because I'm the technologist. I'm like, this is so cool. And she's like, this is creepy. But it did alter our vacation plans in Europe, so it's really cool.
I think again, it's one of those things where maybe even like 18 months ago, you were told that every time you make a new task, you just start a new context window and inject some context, and then let it run. And now I just have like 10 pin threads on my desktop, and those are the ones I work with for like 80% of my work.
Wow, interesting. Cool. So tell me about an area that OpenAI is working on now, or maybe a feature you released that you're most excited about.
I would say it's two things, right? One is just voice in general. Like, I have a hand injury, I can't type that much, and now I can just sort of talk to my AI and have it delegate all these different tasks. And so that's for one very cool experience. And I think the second thing is the fact that compaction really works now. Like, you can have agents run for, like, I have an agent that's been running for like 45 days.
Wow.
Right? And I don't worry about like, is it able to know where it saved a file, or where does it know when to save a file, right? Because it has this memory system built in, again, it just works. And once you have a system that can run for like months at a time that you can talk to with your voice, I think our relationship to computing will change pretty dramatically.
Yeah, so data and memory coming back up over and over again in the topic here, which of course is a topic MongoDB cares about. But just give the audience a little bit more color on the voice. You were telling me the other day, you're like, hey, you've been having debates with OpenAI, while washing your face, and that really prompted me to go home and try out the voice.
Yeah, so the voice model effectively is a orchestration model. And so when you tell it to do a task, it'll actually spin up a different thread on your computer. And so the example I gave you was I've been traveling a bunch, and every time I get back to the hotel, I open up my laptop, I enter voice mode, and I just say, okay, what did I miss over this past like 6-hour flight? Check my calendar. Did I rent a car? Okay, I didn't rent a car. Can you go use computer use and rent me a car? I'm just doing this as I'm like unpacking and trying to figure out if I like brought toothpaste or not. And then when I come back to my desk, I have like 3-4 tabs open on my browser. It is the checkout page for the car rental I need to get. It's like some paperwork I need to show the next place, and I've checked in for the flight tomorrow, and it's like texted to me over like iMessage.
Yeah.
Right? And so it's this combination of both voice creating multiple tasks and computer use that really changed a lot of things for me.
Yeah, I tried it out. It was really cool. You can interrupt it. It can interrupt you. That was really a different experience. So it wasn't just recording a voice memo instead of typing. It was really very interactive. So that was very cool. So for the developers, founders, and engineering leaders in the room, what would you suggest that they prioritize over the next 6 to 12 months if they want to build and scale AI products that truly last?
Yeah, I mean, I think I will say this from the biased perspective of OpenAI, but I think the priority for developers is two things, right? One, how do you give your models like secure access to the data it needs to get the job done, right? And then two, really understand what the job actually is. Again, is it like, I think people don't really have a good understanding of like what success looks like for the agent, but it ultimately is going to be dependent on the data you give it and like some scoring criteria for like how the agent does. Everything else in terms of the harness, I think, is something that like really is going to be hard to like improve on, right? Like as we launch new features like a better compaction or better memory usage, like its ability to remember when to write and when to read, things like doing code mode or computer use, those should be things that you just automatically benefit from as we release a new harness or improve the model. And then your job, again, is to just understand what does success look like and what data and what access do I need to get that job done, and do I need to like do that in a secure way, right? Like, one example I'm working on is a Slack bot. And it's like, I just can't search all of Slack. It's like, whose credentials am I using every time I tag something? These are like the really hard decisions that, really matter for a company.
Yeah, we were talking earlier, and as I kind of mentioned at the talk, sometimes the kind of seemingly boring, the models or voice are the things that really spark creativity. But sometimes it's the cost controls, governance, access control, security that really is going to be what makes or breaks adoption, both in the industry, but then specifically within companies.
Yeah.
And so I think it's an exciting time to be in technology. So thank you to yourself and to folks at OpenAI for bringing technology that's just changing the way we build software.
Yeah, I'm really excited to see this through.
Yeah, thanks a lot. Take care.
Thank you.
Thanks, everybody.
Our high-level goals are de-risking, decarbonizing, and essentially creating efficiency gains all across the maritime sector.
Thank you all for your interest in the hackathon. Because of overwhelming demand, we're happy to announce that you can hack anywhere. Cerebral Valley will distribute
components on the vessels, be it your engines or generators. They could have hundreds, thousands of sensors across the whole vessel. They'll be polling data at hundreds of thousands of times a second, some of them. So you're creating gigabytes and gigabytes of data every day. But historically, this data's just been woefully underutilized. It disappears into the ether. It runs around the local network of the boat and then it disappears. Our customers haven't historically realized how valuable that data can be. And I think as well, connectivity's been the issue. If you have a vessel in the middle of the Atlantic Ocean, for example, and you have gigabytes of data being produced, there's been no way to get that data off the boat, especially live. By the time it gets ashore, again, you've got reams of it, and people haven't historically known what to do with it. I think previously we lived in like an informational drought. Now it's a bit like we live in an informational flood, but no one can swim. Data storage needs, we use MongoDB. There's just been our perfect sort of one-stop shop for everything we need data-wise. The majority of what our data is time series. I mean, we ingest gigabytes and gigabytes of time series data. Mongo's been perfect for that because where the data's coming from and how the data looks, there's always scope for change. What we're seeing generally is a little bit like plug sockets, if you like. Everywhere you go in the world, they have a best practice, but what Mongo does is it's like that multi-plug that you can fit into any plug and then put ours on the back end. The schemaless approach has been really helpful for us. It just allows us to ingest all this time series data in basically any capacity that we need to and any way that it comes in. Our job is coming in and, trying to teach them how to swim and feel like, we're going in, we're doing the analysis, we're taking that data and trying to unlock value from it. And that's one of the things we love about Mongo. It provides so much of the hard work is already done for us. We don't have to go in there and do the hosting, or we don't have to apply resource for optimizations. We do some stuff, but occasionally Mongo just flick a switch behind the scenes and all of a sudden we've gained like a 100% improvement.
Typically, whenever change happens, it's a month. And now with AI, the speed to value is expected to be weeks. If someone can't do it, they will perish. We are into the BFSI, which is basically banking, financial services, and insurance. So we pretty much serve top 5 to 7 banks globally. Overall, we support $2.8 trillion of assets under management, and we power more than 450 million customers. The first challenge is it's very siloed data. We started having some fundamental challenges in terms of the data availability. The whole process is, because it's so tightly coupled, the schema is very rigid. Change requests are taking a few months. With AI, right? It's important for every business to become a kind of a cognitive enterprise. Earlier, you can live with the technical debt for many years and you're still okay to somehow manage it. I think those days are gone. We understood what is the power of MongoDB and how its readiness from AI use cases. I thought, why we have to just fix this OLTP problem or OLAP problem, how we can ensure that take this opportunity to reimagine what the wealth platform should look like for the AI world. We work very closely with MongoDB for their modernization journey. So MongoDB really understood what our current estate looks like, what is working, what is not working, and how the data model can just not lift and shift, but reimagine. First important outcome is we are able to operate in production at a 30% of the cost. From a performance perspective, it is minimum 50 to 70% faster than what it was, and certain things more than 200x. It is giving some invaluable outcomes on the AI use cases where we leverage the MongoDB vector search. We have a production use cases where the accuracy is above 90-95% consistently. This journey helps us to really future-proof ourselves, the kind of a workload that we anticipate for our platform, and also kind of a new user journeys that we can power leveraging the MongoDB and the AI.
Probably the key challenge for any platform is being able to predict the user needs before they're articulated.
Right.
Because usually at the point where everyone is coming and asking for something, we are rarely in the position to be able to respond to the demand. So in a sense, the platforms should be able almost to predict what the needs of the different departments and the groups are, and actually understanding quite well the broader business of the FT, so we can almost connect the dots and know what we can do that will benefit all of the platform users. But at the end of the day, we might have various products, but then at their core, it's our golden star journalism that has always been at the heart of our business. And being able to slice, dice, and surface the content in different ways is critical, whether it be on our website, on our app, social media, through documentaries, whatever. And especially nowadays with the AI boom and the embeddings become more and more popular for solving different problems, having the ability to do vector search alongside the standard keyword search has become the way to go.
Yeah.
But the problem with it is that it's almost like a new territory. The search is a complex problem space. It encompasses areas such as information retrieval, statistical analysis, AI, ML, user experiences. So we felt like we were the first one to try to embark in this journey and develop a search that can work at scale. Because non-functional requirements are also critical. We have more than 1 million readers on a daily basis and many, many searches per day. So it was not only just building a prototype that works, but being able to productionize it and make sure that it matches the quality of our products that our users are expecting. Thinking from architectural standpoint, it was very clear that we can win quite a lot if we can make our content searchable at source, where it is stored, instead of moving it somewhere else into another search engine or another solution. And this was one of the reasons that we decided to give a shot to Mongo At the time when we were starting the project, some of the features were still in development that we needed, but it's kind of almost like a leap of faith. Yeah. And we decided to invest in Mongo not only because of the technology, but because of the partnership that we have established. Mongo Atlas is not just offering a database or a search. What drew our attention to it was that it's kind of a full package, batteries included, if you like to say, a solution. You have a very easy to use console. You can just go. People who are not very technical can even work with it. It abstracts a lot of operational work. It gives a lot of things that you can get from a platform out of the box, like deployments, dedicated search nodes, which is kind of a separation of concerns. So we're not impacting your main workloads by putting the search on top of it. We released the product first to our web users on ft.com. Next, we will roll out this search on our mobile applications. And once the content for all of our titles is established in one place, we will then roll out this search across FT specialist titles so they can benefit from the same technologies and same capabilities that we're using.
Christian Mastronato, everybody in UK calls me Chris. I work in a wider LexisNexis risk solution group, in particular for the ICIS business. ICIS is a business intelligence company, it's a data services company, and we focus on providing basically data of different kinds for different kind of actors in the commodity industry, up-to-date market information, market trends, forecasts, and so forth.
That must put a certain amount of pressure on the back-end systems that you use. Give me a bird's eye view of what the IT estate looks like for ICIS, and then we'll drill down into some of the more exciting things you're working on.
Sometimes I actually joke that this sort of industry is not really about big data in an actual storage sense, but is more about the quality of the information that you manage. In general, our data is very mixed. So we have a lot of numerical data, as you can guess, mainly prices, of course. We deal a lot of prices and what we call fundamental data. But we also have a lot of content because we have editors, journalists, doing research, talking to people all the time. And so what makes ICIS special in this sense is having quantitative and qualitative data that you have to match all the time. And using documents in MongoDB has been very beneficial.
What are you building on MongoDB?
I would split it up into two major areas. One, which is our core business, really about managing the content. So, and we are moving towards a micro front-end architecture for all our web channels. And MongoDB has been fundamental as a persistent layer for all these new transformation of our web applications. And the other side, which is more explorative, is around our new generative AI interface, which is called Ask ICIS, which recently launched in production. In that case, we use MongoDB as a vector database for basically what is a RAG application. The key point for us was let's get in front of the customer as soon as we can. So in that sense, we basically leveraged Azure Cognitive Services Stack plus MongoDB to just get out of the door as soon as we could a chat interface to our customers. Most of the value you're getting is just having customers putting a real question every day into the system, and that is really helping us to understand how the user experience is going to change. Because I think when it comes to RAG and GenAI application, the real transformation is in the user experience and how our customer interacts with our data, which is completely different as it was before.
What is MongoDB like to work with as a non-engineer myself?
The conversation we usually have is basically the speed of transaction. And in that sense, the data quality you want to ensure. When we move closer to slow-moving data that we want to ensure very high quality, especially at the relationship level, of course, we still to go towards SQL. But when we go closer to the customers, and therefore transaction speed starts to become important versus, I would say, enforcing the quality of your relationship in general data models, MongoDB is becoming sort of a default choice for us. We just tried it. It worked out of the box, and that was it.
Yeah, what are your development priorities over the next year?
One area for us where, again, MongoDB is definitely a core element is this transformation of what all of our content creation workflows, which are enabled by web channels because our content creators, they need to access via web system. Then the other priority is around improving the structuring of what we call the central lakehouse structure. The more we can focus on the data quality and in general the quality of the data model and the way we exchange data across all the estate, the more rapidly we can spin out new application. And especially when it comes to Gen AI, you clearly see the typical computer science rule, garbage in, garbage out. And then these are sort of two foundational elements. And then on top of that, we are what we are calling at the moment the AI factory, building a set of tools where we can easily spin out new AI application.
What do you think you need to do to make that AI factory kind of most effective for the business? What processes are you still refining there to build replicable, easily deliverable AI applications? What do you think still needs a little fine-tuning?
We need to make still certain steps to structure very well the data dictionary in general, the data mesh as a clear domains and bounded context to basically access data in a structured way with the quality that you want. So that's definitely going to be a step. And then the other element is set up a set of tools available to our internal users to build these applications. GenAI is one of those, but we're thinking you definitely want to go beyond that. For example, one of the areas that we are exploring a lot is knowledge graphs, which we believe is going to be a core element and also possibly a competitive advantage to being able to build our own knowledge graph and being able to structure it in a way that can be automatically accessed. We believe is going to be a big change.
Data is really the foundation for any AI or ML or Gen AI application. And this is where a lot of times most of the energy goes. And data, it means how you store it, how you process it, access it. A lot of focus today is on vector databases, but in real world application, you'll have all the different models of access to the database. For example, you get a user logged in, you need to have a user table that gives you a user context. Then some of the content that you're asking about may be structured, like you're asking, what's my account balance? The bot will not go and search it in a document. It will go through a tool to a database and query the user transaction history and so on. Within McKinsey, what I do is I help mainly tier 1 clients of McKinsey in how to adopt AI and Gen AI in scale and productize it. Because we've seen that one of the biggest challenge for companies in that space is moving from playground prototypes into productization and scale that's reproducible. So this is my role within McKinsey, and my team's role is how to help clients reach that point. What we'll work with the clients is on those two areas. One is how to build, let's call it the platform for AI and Gen AI that will serve the various aspects of life cycle and do it right, with all the aspects. And as the second is when they want to implement a use case, we have deep technologies that done that for multiple clients, and then we can build the same thing for that client. So we're usually doing both. I think first there is an issue that people go read some buzz, read some Medium articles and so on. Oh, it's so easy to go and implement. Or even sometimes we see the vendors, because they want to get higher adoption, it's really easy, just like do this and this and this and off you go. Because again, their interest is to push more and more people to use those LLMs and their cloud frameworks. And then we say, no, you can't just take a PDF and upload and that's it. What about the versioning of that document? What happens when the version changes? What do you do when you have 1,000 documents? How do you manage them? How do you manage metadata and so on? Even subtle changes that we've seen with OpenAI that broke the application because the prompt was interpreted in a different way. So if you don't build that into your process, so for example, testing before you go to production and validating and only then going to production, just as an example, it could be a big issue. So what we like about MongoDB, for example, is twofold. One, I don't really care what's the model of data access I need. In the same application, I may have 5 patterns, key value, graph, vector, relational, and document. So that's one key advantage. I don't need to work with 5 different types of database, each one with its logging, authentication, so on. The second is that MongoDB has the enterprise maturity for the other models and just extended it to vectors and versioning and so on.
All those fundamentals that you refer to.
So you get something which is production ready on one end without patching and so on. And you get to choose what's your you have an a la carte menu of data access patterns. Essentially, every Gen AI use case that we see could be deployed using MongoDB and Atlas, and as I mentioned before, it's actually very convenient that I don't need to install MySQL and then install the Milvus or whatever vector database, and maybe I need the graph, so I'll go Neo and so on. So I have a cloud service, I can play around with it, just credentials, even a freebie option, and as I go to production, I'll turn it into more of an enterprise license and so on.
Most businesses are stuck in the chatbot era, but the real competitive edge isn't an AI that talks, it's an AI that acts. In the next few minutes, we're going to map out the evolution from basic LLMs to autonomous AI agents and why your data platform is the single biggest factor in making that leap successful. We're moving past simple prompts. What comes next is a system that doesn't just answer questions, but manages complex multi-step workflows using MongoDB as the stateful backbone. The progression of AI can be seen as 3 waves. It started with wave 1, large language models. These gave us conversational access to a model's built-in knowledge. For the first time, users could tap into vast built-in intelligence simply by asking a question. It removed friction, accelerated workflows, and changed how users interact with information. It was a massive productivity boost, but it had a ceiling. It didn't know your business. That led to wave 2, retrieval augmented generation, or RAG. By connecting models to your organization's private data in real time, AI gained context. It stopped guessing and started reflecting your systems, your language, and your operational reality. But now we're entering wave 3, agentic systems. This is the frontier. AI is no longer just answering questions, it's taking action. Autonomous and collaborative agents can analyze environments, reason about complex tasks, and proactively move toward outcomes. From a technical standpoint, an agent follows a sophisticated loop. Unlike an LLM, which returns text based on data, or RAG, which returns text based on data and external documents, an agent interprets the user's intent, breaks it into multi-step plan, and executes those steps via APIs. The key differentiators of agentic systems lie in its autonomous decision-making, chain of thought, contextual awareness, and the ability to learn. But an AI agent needs more than just access to a model. To do this at an enterprise level, agents require 3 core capabilities: memory, semantic understanding of enterprise data, and the ability to act within operational workflows. First, memory. Agents need both short-term to maintain context during reasoning loops and long-term memory to store knowledge, past outcomes, and evolving state across interactions. Second, intelligent retrieval. Agents must interpret intent from multiple perspectives and retrieve the most relevant context from large volumes of unstructured and structured data using semantic search. And third, actionable integration. Agents must connect to real systems and orchestrate workflows across API services and tools. Let's talk about memory. Short-term memory keeps the current reasoning loop coherent as the agent plans and executes tasks. Long-term memory stores knowledge across sessions, previous outcomes, learned patterns, operational data, user preferences, and historical context. Without both layers, agents lose continuity. Every interaction becomes a reset instead of an evolving system that improves over time. But memory alone isn't enough. Agents also need to interpret intent and retrieve the right context from enterprise data. That's where intelligent semantic search comes in. Instead of matching keywords, agents can retrieve relevant knowledge across logs, documents, telemetry, and multimodal content based on meaning and context. This allows the system to reason from multiple perspectives: operational data, historical events, and real-time signals, before deciding on what action to take. On to integration.
Our next session will begin in 5 minutes. Please take your seats. MongoDB.local Build Fest continues. Now, please welcome MongoDB Field CTO, Pete Johnson.
Thank you. Thank you very much. You have a choice for how you spend your time here with us here at BuildFest today. I appreciate you chose to spend it with me, or if you chose to be at the last session and just didn't move and decided to stick around in the same room. I see some heads nodding. So welcome to Make Every Developer an AI Developer, the jQuery moment for AI. Before I get into who I am and we get into the core of the session, quick show of hands, who in the room is in their 20s right now? That's what I figured. We got a large number of those. How about some folks in their 30s? All right, now we're getting a little closer to me. Anybody in their 40s and 50s? Any fellow Gen Xers raised on neglect and hose water? So the jQuery moment for AI, if you're in that last group, you know exactly what I mean by that. If you're in the first two groups, I'm going to need to give you a little bit of context for what I mean by the jQuery moment of AI, and I promise you I will get you there. But first, just real quick, my name is Pete Johnson. I'm the field CTO of AI here at MongoDB. I wrote my first line of code as a sixth grader in 1981. This picture here was taken on my 12th birthday in February of 1982. If you look very closely, that is a TRS-80 color computer. That was my first computer. That bad boy had 4K of memory, and I don't want to brag, but it had 7 colors. 7. 9 if you count black and white. If you look very closely into that picture, on the left-hand side of that 11-inch Magnavox color television is a audio cassette recorder. So I'm not punch card old, but I am audio cassette player as storage old. And sir, by the smile on your face, I can see that you and I are already locked in. I've worked at lots of places that you've heard of, a couple that you haven't. I've been here at MongoDB for about 14 months now, when I get to go all around the world and talk about AI. In fact, you know, this year through the end of July, I've been to 7 different countries. I've talked to 100 different customers about where they are on their AI journey. I've been having this kind of world tour where I go to different stops around the world. San Francisco here is the second time I've been to San Francisco this year. It's stop number 23 in 7 different countries. So I've talked to a lot of people about where we are in our collective journey as an industry around AI, and I can tell you a little bit about what I hear most often collectively across these different organizations. We're going to spend our time in this way. First, I'm going to talk about this movie that we've seen before, and this is the jQuery reference that I made at the beginning during the title. Then I'll talk about how I feel like we're at this jQuery moment for AI, this point at which we're beginning to see things become easier for a larger group of people. Something I'll say a little bit later, but I'll say it now too. More people will build agents in the next 3 years than did build agents in the last 3 years. And how do we do that as an industry? We have to lower the learning curve. We have to make it easier. This is this jQuery moment that I'll talk about here in a minute. And then we'll review and we'll talk about some next steps that you can take in your journey. So let's first start with this movie that we've seen before. So the first poll I really saw that I liked this year was the first week of February when Crew AI put out this study. They surveyed about 500 C-level executives, found that 65% already had some form of AI in production, and 100% had plans to expand that sometime in 2026. So this was reported back in the first week of February by our friends at Crew AI. That very same week, DigitalOcean put out a similar study. They had a slightly wider end. They polled about 1,100 people. And they found that only 15% are training their own models. So what everybody else is doing is using alternate techniques to get their proprietary data into AI pipelines. And we'll talk about what that looks like here in a minute. The key stat there at the bottom is most organizations are building AI solutions with basically popsicle sticks and chewing gum, putting together AI solutions with hybrid stacks or niche tools in some way. That's where we are. And to those old timers that raised their hands with me at the beginning, this should sound familiar. So my first web application went into production in January of 1996. And by modern standards, its architecture was objectively terrible. It was about 8 different CGI bin Perl scripts. I did not see, not only did I not use CSS because it didn't exist yet, HTML tables were not yet part of the HTML specification. So I had to use pre-format tags for all those kinds of things. It was about at that point in the existence of web applications that JavaScript was first introduced into browsers. So this was in about 1995. As we'll get into here in a minute, you could use JavaScript at the time to create desktop-like applications in the browsers. But this was difficult. It took a lot of skill. It took somebody who really studied how to do this, and we'll get into some of the details as to what that looks like. But then in 2006, we got a new library, and it was called jQuery. And jQuery enabled even an early stage career developer to be able to do things that only that senior developer could do before. If you raised your hand when I said if you're in your 20s and your 30s, you probably have never heard of this. And the reason you've never heard of this is because we've had an additional layer of abstraction get introduced into this ecosystem. You probably are all using some form of React or Angular. Those two things stand on the shoulders of jQuery, which stand on the shoulders of raw JavaScript. Imagine trying to go down to that raw JavaScript now and how difficult that would be. Think of all the benefits that React and Angular give you today that allow you to create new applications very quickly. This is why we have full stack engineers today. It's because it's so much easier than it was back in the day to create these compelling UIs out of your web applications. So what does that look like in terms of AI today? And how do we make it so that we can lower the learning curve, make it easier for people to use, so that, like I said a minute ago, the number of people developing AI applications in the next 3 years will be more than they have been in the last 3 years. So how can we lower that learning curve and make it easier? So back in the JavaScript days, this sort of pain was real. And the old timers in the room like myself can confirm, if you ever had to use raw JavaScript, you were constantly having to deal with browser changes and how browsers interacted with the JavaScript was very different. Internet Explorer did different than Netscape Navigator, than did Firefox and so forth. The code itself was very brittle because you had to navigate this thing called the DOM, which was the document object model, the way that that JavaScript got the HTML described to it and how you had to navigate it in certain ways. There was a scarcity of talent. There were very few people who knew how to do this well. So, they were very well paid, but it slowed down the development process. And it's this last part that's still relevant today. The number of people that know how to deal with things like embeddings, that know how to deal with things like re-rankers and so forth. This is a very small subset of the overall developer community today. And one of the things that we've done here at MongoDB is we've placed an emphasis on making that easier so we can make it accessible to a wider group of developers. And hopefully you've experienced that in some of the other hands-on sessions that you've had today. But I'll be describing some of the features that we have that make that possible. So this pain is sort of back. And there's these 5 core things that you end up having to deal with if you're building a RAG pipeline or you're building agentic memory. Those 5 things are as follows: chunk size, number of dimensions, token cost management, API key management, and embedding maintenance. I'm going to walk through each of these 5 here in a minute, but for the last time, I'll make this analogy back to the jQuery. On the left-hand side of this slide, you see some code that you would need in order to find a particular part of the HTML, which you could then manipulate to make a more desktop-like UI back in the day. But when we got JavaScript, or when we got jQuery, that got reduced to a single line. My Gen Xers in the room, this probably looks familiar to you. It probably the first time you saw this, it was magic. It was black magic in a way that you didn't have to navigate this before. But if you're younger, you never had to deal with this because you have no idea what I'm talking about right now, right? Right? Because now you've got, we've advanced well beyond jQuery to things like the React and the Angular. So what I'm going to spend the rest of our time doing here is walking through these 5 stages, talking about what MongoDB has done with these features that you need to make this easier, to make it more approachable. And then we ought to have time for some Q&A at the end. So let's move on to this jQuery moment for AI. So before we get into the core 5 things, let's talk about context. Why does vector search matter? What's so important about this? And core, how does vector search work? Let's talk about first why it matters. So if you go back to the fall of 2022 and ChatGPT first hit the marketplace, this is what the application architecture of ChatGPT looked like at the time. You have a query. It gets placed into the context window of the LLM. The LLM does its magic and generates some result. And as simple as this application architecture was, it did amazing things. By the time we got to the spring of 2023, you started to see headlines in mainstream media like ChatGPT passes the bar exam. And I happen to live with somebody who passed the bar exam, and they were pretty pissed off when that happened, to be honest, because now AI could do something that took her 4 years to learn how to do. But it was a very simple application architecture, but it had 2 key flaws to it. And it has to do with the way that LLMs are trained and then put into production. So problem number 1 is LLMs are trained on public data. So how do you inject proprietary data into an LLM without going through an expensive fine-tuning or an expensive retraining process? So problem number 1, how do you inject proprietary data? Problem number 2, at some point, every LLM has what's known as a knowledge cutoff. There's a point after which the LLM doesn't know anything about the world, because at some point, if you're OpenAI or if you're Anthropic or Google, you have to stop training the LLM and you have to start to put it in inferencing mode. So anything after that with this simple architecture, you don't know anything about the world. So in the spring of 2023, if you had asked ChatGPT, what's MongoDB's stock price today, can't tell you, because that's information that took place after the end of that knowledge cutoff. So we spent the last couple of years trying to figure out how do you overcome those 2 limitations. And in 2024, RAG became widely used. So retrieval augmented generation, you've probably talked about this in some of the other sessions today, that instead of taking the query and putting it immediately in the context window, the first thing you do is you go through a data ingestion phase where you take some of your data, you pass it through an embedding model like Voyage AI, you put those embeddings into a vector database like MongoDB, and that's your data ingestion phase. At query time, instead of taking that query and popping it directly into the context window, you instead go on a side quest. You take that query, you pass it through the same embedding model that you used during the data ingestion process. You then go find documents that are similar in content, in topic, to the query. And you take the query, and now with your retrieved documents, you put them together into the context window, and that's how you get the LLM to forget who the last 30 Oscar winners were, and you get it to look at your proprietary problem. It's how you get it to focus. This became very popular in 2024. But what about that real-time data? In I think it was the Tuesday of Thanksgiving week in 2024, is when Anthropic published the Model Context Protocol and made a standard way to provide tools, tool definitions, which really are facades on top of external APIs to the LLM. So the LLM now had a way to go get external data, and that's why when you ask ChatGPT today or Claude or whatever your favorite chatbot tool or agent might be, if you ask it, what's MongoDB stock price today, and MongoDB stock price is doing pretty well today, by the way. If you ask that question, that's how it is able to go grab that information, is with those external tools. The other thing that we started to see in 2025 is this notion that there's a looping construct here, where you take the response from one of these loops and it now becomes the query for the next loop. And if you're going to do that over and over again, the context window is stupid. It's empty. You have to refill it every time. So if you refill it every time, you need some notion of agentic memory or session memory to keep track of what's happened in the different loops. So together, the important part of an agentic architecture for which vector search is relevant are the RAG pipelines at the bottom that solve that proprietary data problem, and the agentic memory so that you can keep track of what's happened either across a current session or across multiple sessions. Every modern agent has these two problems. This is why vector search becomes so critical to any agent that you might be building, this is why this is relevant. But maybe nobody's ever explained to you, like, what is actually happening under the hood here, and what are some core choices that I have to make when I'm implementing a particular vector search? So we talked about what these 5 things are: the chunk size, the number of dimensions, the token cost management, the API key management, and the embedding maintenance. But let's first have a quick primer on how vector search actually works. Anybody who has taken algebra understands a 2-dimensional space. Ultimately, what a vector search is it's taking real-world things, whether they're text or images or audio, and it is transforming them into some mathematical space. So what we're going to do here is we're going to take the simplest example possible, where we're going to take 2 dimensions, so just x, y, like we've got here, and our corpus of data is just 4 words: dog, cat, apple, orange. So if you take those 4 words and you pass it through an embedding model, what you're going to get for each of those is an x and a y to map in the 2-dimensional vector space where each of those words should reside. The embedding model knows some things about the real world, and what it does is it places, in this case, words, the vectors that represent the words, closer to one another when they are semantically similar. So this is different than a traditional keyword search, which relies on things like word roots. But instead, because we're taking, in this example, words and mapping them into vector space, this is why you see dog and cat are closer to one another, and apple and orange are closer to one another in the vector space, because apples and oranges are both fruits, dogs and cats are both animals. So that's how the basic structure works. But what happens when we go to query this? Suppose I go to query this with the word kitten. As English speakers, we understand the relationship between the word cat and the word kitten. But this is where a lexical search, a keyword search, will fail, because cat and kitten don't have the same word root. So a lexical search will fail here. But a semantic search that understands things about the world, when it translates the word kitten, it knows it is in a similar space in the vector space to what we see here with the word cat. And that's how, when we do a semantic search, we get better results, more relevant results than we would with a traditional lexical search. So in this very trivial example, our chunk size was single words. Our dimensions is 2. That'll become relevant here in a minute. So that's the basics of how vector search works. So now let's walk through each of our 5 things that we're trying to make easier, that MongoDB is trying to lower the learning curve, trying to give you some time back so that you can use it on your business logic instead of figuring out the plumbing. And let's start with chunk size. So the trivial example that we just used, the chunk size was words, right? We're looking at the fidelity of words. It's more common for you to take the chunks and want to do the fidelity of, say, sentences or paragraphs of text instead of words. I just use the words because that trivializes it, makes it easier to understand the basics of how that vector search works. But if I'm trying to use something in real world, how do I know what's the right chunk size? It turns out that if you make the chunk sizes too small, you lose the context, let's say, of the other sentences in the paragraph around that fidelity of the sentence. If I'm trying to get to the fidelity of a sentence, sometimes the context of the paragraph around it or the page around it matters for the context of what you're trying to search. But if I make my chunk sizes too big, after a while, I start to lose it starts to lose the focus of the individual sentence that I might be after, and it definitely starts to drive up your storage costs. So the situation that it puts a developer in is, what's the right chunk size for your use case? I don't know. I got to try. I got to iterate over different sizes of chunks to see, I try this once at a certain chunk size. I see what my retrieval quality is and what my storage cost is, and then I try again at a different chunk size. What if there was a better way to do that? What if there was a way that we could automate the chunk size, or a way to make it so that you wouldn't have to spend so much time iterating? What if you didn't have to make that trade-off between retrieval quality and storage costs? And that's what contextualized chunking does. So we first introduced this last summer with the Voyage Context 3, and that's the graph that I'm showing here. The Voyage Context 3 has since been superseded by the Voyage Context 4, which we announced last month. I got to announce that one on stage at .local Bengaluru. What this slide here on the right-hand shows, in the blue there, the predecessor to the Voyage Context 3 was the Voyage 3 Large. And you can see you've got retrieval quality on the y-axis there, and you've got chunk size on the x-axis. And you can see that as you increase the chunk size with a traditional embedding model, one that does not support contextualized chunking, you slowly get slightly better retrieval quality as you increase the chunk size, but there comes a point at which, when your chunk size becomes too big, you actually start to lose retrieval quality. And as your chunk size becomes bigger, you've got bigger storage costs that go along with that. But the Voyage Context 3 introduced a different way to do this. Instead of sending us one block of text, you send us two. You send us the fidelity you actually want to embed, and then separately you send what the context is that you want. We'll combine those as we generate the embeddings and generate that array of floats for you to put inside your document to create your vector index for. And what we found is this actually inverts the process. That when you do it that way with contextualized chunking, you can get better retrieval quality at a lower storage cost, at a smaller number of tokens in your chunk size. It's so much better that you can choose an arbitrarily small token size for your chunks and get good retrieval quality. So now you no longer have to go through that iterative cycle to figure out what's the right chunk size for the retrieval quality and storage costs combination that I'm looking for. With contextualized chunking, you can just choose something arbitrarily small. You get great retrieval quality at a lower storage cost. So that's the first of the 5 that we're lowering the learning curve, giving you some time back to work on your core business logic. We have a similar problem when it comes with number of dimensions. In the trivial example that we talked through a moment ago, we had 2 dimensions. In the real world, you might have 1024 dimensions. Now, I can't think in 1024 dimensions. Maybe you're a lot smarter than I am, and you know how to think in 1024 dimensions. But when I went through the trivial example, I just showed 2 dimensions. It's more common to try 1024 or maybe 2048 or 512. These are common sizes that you might use for number of dimensions. The greater number of dimensions you have, the richer your vector space becomes, and generally speaking, the better retrieval quality you get. But that comes at a higher storage cost. So what's the right number of dimensions for your use case? I don't know. You got to iterate over it. You got to try. So with a traditional embedding model, if you take your corpus of data and you embed it, let's say at 1024 dimensions, and now I want to see what kind of retrieval quality hit but boost to storage cost what I get if I did 512. With a traditional model, you would have to take that corpus of data that you already ran through at 1024, and you would have to run it again at 512, but not with the Voyage models. The Voyage models have a feature called Matryoshka representation learning. And what that means is the name is taken from Russian nesting dolls. So think about what a Russian nesting doll is. You've got like the big one, right? And you take it apart, and inside is one that looks very similar, but at a smaller fidelity. And then you can do it again, and you can do it again, and you can do it again. This is a fancy way of saying that if you take your corpus of data and you run it through a Voyage embedding model at 1024, the dimensions are ordered. So if you want to see what kind of retrieval quality and storage costs you might get at 512, you don't have to run your entire corpus of data through the model again. You already have what you need. You just lop off the last 512 and only use the first 512. So this means fewer iterations for you. It means less time for you to do your testing, lowers the learning curve, gives you more time back to use on your business logic. So that was dimensions. So we talked about chunk size. We talked about number of dimensions. Next, let's talk about token cost management. With a traditional model, with a traditional embedding model, you have to embed your corpus of data, generate your vectors, store that in a vector database, and then when you're going through your development cycle, you then have to embed your queries with that same embedding model as you're developing your agent and your web application. With a traditional model, you're going to have to pay token costs both for the embedding the corpus of data and when you embed your queries when you're in development. But we thought, you know what, there's a better way to do that. You shouldn't have to pay for embedding the queries at development time if you don't want to. So in January, we introduced, as part of the Voyage 4 text embedding models, a new concept called shared embedding spaces. So it's typical for an embedding model vendor to have different sizes of the models. And in Voyage has traditionally, we've done small, medium, and large. Small, medium, and large have different price points and different retrieval quality. But for the first time, we introduced the Nano, which is an open weight version of the Voyage Context 4 model. Not only did we introduce the Nano, which you can download from Hugging Face, and you can even run it on your laptop if you want to, but all 4 of those models share an embedding space. And what that means is that any embeddings generated by any one of those 4 models is compatible with the other 4 models. Practically what that means is I could embed my corpus of data with the large, but then while I'm in development, I could embed my queries with the Nano and avoid token costs during development altogether. So it's a choice that we give our customers so that you can lower your overall token burden. And token maxing has become an important conversation here the second half of 2026. But it gives you the option of not having to pay for token costs while you're in development, and then when you go to move to testing or you go to move to production, you get to choose. Do I go back to the large in the example that we just talked about, and you take a little bit of a retrieval quality hit if you use different models? They are compatible, but they do have a retrieval quality penalty if you mismatch one with the other. But again, what we're after here is the ability to help you lower token costs, make it easier on you to develop solutions with MongoDB and Voyage AI for either those retrieval augmented generation pipelines or for that agentic memory. So we talked about chunk size, we talked about dimensions, we just talked about token costs. What about API key management? One of the ways you can implement this is you can have your core data in one database, you can have your vector data in a second database, you can have a different vendor that you're using for your re-rankers, and another one altogether for your embedding models. And you could stitch all those things together and manage them yourself, but why? Why do that when instead you can manage all of those things from one place in the Atlas console? So instead of having to stitch together different solutions, what MongoDB offers is a single platform for your core data, for your vector data, for those embedding model API keys and for those re-rankers all in one place. So that instead of spending operational cycles managing the stitching together of all those things, you can just set it and forget it. You can just go to one place and use all those things together. So far we've talked about the chunk size, we've talked about the number of dimensions, we've talked about the token cost management, and we talked about API key management. I would argue to you that those four things collectively help move the needle from raw JavaScript to jQuery, if you follow the analogy that I've now laid out. This last one, though, I would argue starts to get us into React and Angular world, and that has to do with embedding maintenance. So think about how this works. So when you take your embedding, so that's just your array of floats, and you put that in your MongoDB document, you then generate your index off of that. What happens when the core data changes? So suppose I have a field where I've got the synopsis of a movie, and I've embedded the synopsis of that field, that text field, I've embedded that with Voyage AI, and I store the vector, the resulting vector, in the same documents, and now the synopsis changes. If I'm managing my own pipeline, I'm now responsible for observing that change, for triggering off of it, for embedding the content again, and for updating the index. Well, you don't have to do that anymore, because MongoDB has this feature called auto embeddings, where if you take a look at that JSON on the right-hand side, you tell us what attribute you want to embed off of. You tell us what Voyage model you want to use. And there's other optional things where you can tell us what the number of dimensions are and the chunk size and so forth, or we'll default off of some of those. And we'll automatically do the maintenance for you. So what that means is anytime a document that has that field in it, the field that you specified in that JSON, anytime data in that field changes, we will automatically take that data, run it through the embedding model, update the vector, and update the vector index for you. Or if a new document shows up in that collection with that attribute, we'll automatically take the content in that attribute, run it through the Voyage embedding model, store the vector for you, and update the index, so that you no longer have to worry about the maintenance of that vector content yourself. You now have the ability to take that time and spend it instead on your business logic. So let's review. So we talked about the premise of the talk here is that we're trying to make it so that any developer can be an AI developer. And how do we do that? By lowering the learning curve, by lowering all the details that you otherwise would have to take advantage of yourself. Those details around finding the right chunk size, around finding the right number of dimensions, about trying to avoid token costs, trying to make it easier to manage your API keys across 4 potentially different platforms. Instead, you can get it all from one place. And then what we just talked about with the embedding maintenance. And the analogy that I make here is that jQuery changed everything for web development. What we're trying to do here at MongoDB is make a similar change in the ecosystem for AI, to make it so that these 5 things that you would otherwise have to manually deal with yourself, we're lowering the burden of dealing with all of them, so that you get time back in your day to go work on other things. That's all I have in terms of my formal remarks here. In my travels all around the world and talking to different people and writing different things, I do a lot of writing on LinkedIn. You're invited to, with that QR code, you can follow me and see the kinds of things that I'm seeing out there in the market, so that you don't have to follow them yourself. I'll literally connect with anybody, DM's open. Any questions you have about this session or about anything that happened here today, happy to do so. We've got 11 minutes based on the clock in the back for any Q&A that we might want to do, or if you want to get cut loose early, that works for me too. I think we've got a microphone out here somewhere, don't we? Yeah, Krista's got a microphone over here. You're not going to hurt my feelings if you don't have any questions, but it's better for everybody if you do. Yes, ma'am. Krista, we've got somebody right here.
Thanks for the talk. I learned a lot, especially I'm a front-end engineer. So seeing the history from JavaScript to jQuery to React, that energy really stayed with me. I have a question about like MongoDB database. So nowadays we're seeing also a lot of folks pairing, let's say, Postgres Neon database with another vector database, let's say like VV8, etc. What are some of the advantages MongoDB offer other than those combinations?
Sure. So the question for those that didn't hear it is, some people use combinations of database to achieve some of the RAG pipeline or the vector or the agentic memory we just talked about. What are some of the advantages that MongoDB offers above and beyond that? So fundamentally, the advantage is that you can get it all on one platform. So instead of having to stitch things together yourself, like have your core data in one place, your vector data in another place, you can do it all here with MongoDB. Because if you think about this, what's a vector? A vector is an array of floats. And because we're based on JSON, at the end of the day, what MongoDB does is we take a wad of JSON and we're serializing it to disk in BSON, right? That's at the end of the day, that's fundamentally what we're doing. So what's an array? What's a vector? It's an array of floats. So within JSON, all an array of floats is an additional attribute. So if you've already got your core data in MongoDB, adding vector search to it is as simple as adding an additional attribute to a data set you already have. So you don't have to have a second vector database and separate from your core database. You can have it all in one place. The cool thing about the way that works, though, is that data that's in a collection doesn't necessarily all have to have the same shape. So suppose you had 1,000 documents and you only wanted to generate vectors on 500 of them. Okay, that works for us because when we generate the index, the vector index off of, we're only going to look for documents in that collection that have the vector. So if you certainly are welcome to vectorize all of them, but if you only wanted to vectorize a subset of them, you can do that as well. And again, it owes itself completely to the way that we've implemented the vector search on top of the very flexible document model, on top of the flexible JSON. Did that answer your question? Thank you so much. Anybody else? We got 7 minutes and 50 seconds. Did we see somebody else? It's always a troublemaker in the back. Always. You're going to make Krista run or jog throughout this room. Yes, sir.
Thanks, great talk. I agree, there is no LAMP stack for agents yet.
There is not.
So, right. So I'm wondering what you're seeing out there about the movement between or to or from like vector search with semantic searching versus agentic search. And what I'm referring to is when Claude Code first came out, I think they made this kind of surprising, opinionated take on the design, which was instead of favoring vector embeddings with kind of semantic searching, they just said, we're not embedding anything. We're just going to do agentic search over your code base.
Yeah.
In fact, if I remember correctly, on some podcast, they said an internal early version did use embeddings, and it sucked. So how are you seeing the kind of trade-offs between kind of embedding semantic search versus never mind all that?
Yeah.
We'll just do it live at runtime.
Okay, so good question. So to summarize, why vector search? Because there's an example in Claude Code where this is true. If you dig into the code leak that they had in the spring, how does Claude Code memory work? It doesn't use vector search at all, right? It uses a completely different structure. If there's one thing you remember about what I've said on stage here today, it's this. As an industry, we've been building databases for 60 years. We've been building agents for 18 months. What's the right way to do this? It's still evolving. So here's the argument for vector search. The argument for vector search goes like this. A lot of the data that you might want to put in that context window is unstructured data. How are you going to comb through unstructured data in an efficient way? I've already talked about why lexical search on its own might not be the best solution. But if you're trying to find content that is similar in topic to whatever the current loop is, whatever the current query is on the agentic loop, vector search is a great alternative there. But the kind of vector search you use matters. So someone else, you can find this pretty easily, and on the Voyage pages. Most people think that embedding models are that all embedding models are commodity, that they're all created equally, and they are not. We've got plenty of data. There's a benchmark that Hugging Face publishes called RTEB. RTEB shows that the Voyage Context 4 text model is 14% better than OpenAI's model. Anthropic doesn't have their own embedding model. They recommend us. There are use cases for which that 14% makes the difference between a hallucination and a correct answer. So the blanket statement that vector search sucks, which, to paraphrase, that's what you said, you're certainly entitled to that opinion, but it depends on what you're talking about. Are you using some commodity kind of embedding model, or are you using something good that makes it easy to choose chunk size, that makes it easy to scale down on different dimensions, that makes it easy to lower your token costs? Depends on what you mean by good. It depends on what all you tried. If you only try, one of those other embedding models and you don't fiddle around with the dimension sizes and the chunk sizes to try to boost the retrieval quality, it's not really an apples to apples kind of comparison. So like anything else, don't believe me, get your hands on with this stuff and try it yourself. I would say, if you've read something about that vector search isn't enough, for some use cases, maybe it isn't. But for a lot of use cases, it is. And especially when you consider that our vector search isn't necessarily just vector search alone. So because of the way that we implement this, like I said, what's a vector? A vector is an array of floats. Well, if you put that array of floats into another rich document, upon which you can also do lexical search in addition to the vector search, so you can do a hybrid search and get the best of both worlds. You can also do things like pre-filter, where maybe if my data has data about books, and I want to do a lexical search on the title, but I want to do a vector search on the synopsis, and I want to pre-filter out all books that were written before 2001. I mean, those are some of the levers that I have with the richness of the MongoDB query language that can get me far more precision on what I'm looking for than you can get with just a de facto vector search on its own. So look, I'm 56 years old, man. The answer is always, it depends. That's always the answer, right? But what I would suggest you give a chance is try vector search with a better embedding model. Try vector search with a higher number of dimensions. Try vector search with different chunk sizes. Just because it didn't work for you with one of those combinations doesn't mean that it won't work for any of the combinations. And you can try it in combination with pre-filtering. You can try it in combination with the lexical search. And we have things in the pipelines that make it easy to do things like do the re-ranking with one API. So you can do both a vector search and a re-rank with one API call. You can do a hybrid search with one API call. The aggregation pipelines, those are some new verbs that we just announced as well. It's a richer set than you think. And like I said, don't take my word for it. Try it yourself. Thank you for the question. I always appreciate healthy skepticism. Thank you. We've got 1 minute and 20 seconds. Real quick, sir.
I got a quick question.
Yeah.
So you talked about
Is this thing on?
Hello?
There we go.
So you talked about, from my understanding, you talked about 5 things that MongoDB offers to kind of help evolutionize of like building agents,
yes,
right? Do you think it might be worth it to hone in and really focus on maybe one of those things? Or do you think that what MongoDB offers is more of like it's more doing all of them at once? Or do you think it might be beneficial to try to like, say token optimization? Do you think somebody could really like use MongoDB to do that?
So where do you
really well?
start is essentially what you're asking, right?
Yeah.
This is a big, rich space. Where do I start? I think if I was to pick one of the 5 to start on, the thing that people struggle with the most is typically the chunk size. It's easier to get into the downscaling of the dimensions. It's way harder to play around with the chunk size. And like I said, we just had the Voyage Context 4 get released last month. I would start there. That doesn't mean that you don't graduate to the others, but if you're looking for like, hey, which one is more important? Dude, there's a reason why I led with chunk size. I would start there. So I'm out of time, and I got another thing I got to go get to, but I'm the giant bald guy. It's really easy to find. If you want to ask me questions later on throughout the day, I'm going to be hanging out the rest of it. Otherwise, thank you so much for your time. You've been a great audience.
Our thanks to Pete Johnson for all of your questions. Our next session on the stage will begin at 3 o'clock. If you're staying here until then, we'll come scan your badge.
Hi, I'm Liz Hill, a staff product designer.
And I'm Ben Perlmutter, a senior AI engineer.
And today we're excited to talk to you about the AI Assistant program at MongoDB. So first we're going to talk a little bit more about how we built it, and I want to hear about what was the moment that we realized we wanted to build an AI assistant in the first place.
Absolutely. So we started thinking about the problem in December of 22, but then it was in the winter of 23 that we built the first real robust prototype, which we actually built during an internal hackathon that we have regularly called Skunkworks, kind of a fun name. So a group of us, I think it was 5 people, we were just heads down trying to make this thing a reality. Now, creating a chatbot or an assistant like this is kind of table stakes in the AI industry or the tech industry more generally, but at the time it was quite novel. There was 1 or 2 blog posts that we were basing our project on, and also concurrently to this, and conveniently for this product at MongoDB, MongoDB had just released an internal preview of Atlas Vector Search, which allows us to do AI-based search to power the whole experience. So we're able to use that to make the product work.
Exciting. Sounds like a fun project and hackathon. I remember seeing that come out and being very impressed.
Oh, thank you. Yeah, it was a lot of fun to work on. And with that in mind, well, this was a fun thing for me as an engineer to build. What for you, from the product and design perspective, made you want to put in front of our users?
Yeah, I mean, we were so excited to see that there was this assistant chatbot up and working, and we knew that it had the opportunity to solve a whole lot of our users' problems. Obviously, we have a huge documentation site. It's really robust and well written. But at the same time, we wanted to be able to allow users to find the exact information that they needed far more quickly. And so I think we knew that this would give us the opportunity to deliver that to our users. And it was great to see it expand across our university platform and then .com for people who are even thinking of adopting MongoDB. And then it's been great, however many years later, now it's in the product, helping people understand what cluster configuration is the best for them in Atlas, helping them to debug their connection strings in Compass or generate queries, and even interact with their data. So I know the product design team is talking to users and already thinking about what's next for the assistant. So I think that there's a whole bunch of user problems that we're going to be able to use AI to help.
Absolutely. Yeah, it's been really interesting to see how, as the AI models themselves that power all of these experiences, as they get better, we're able to just deliver better and better experiences to users with them.
So now I'd love to talk about how we actually built the assistant. Can you talk a little bit more about what actually happens when a user asks the assistant a question?
Absolutely. So the assistant is what you could call an AI agent under the hood. Every time you send a query to it, there's an AI model that decides what to do with that query. So sometimes it'll just answer directly or call a tool if a tool is provided by the end application. Like, for example, in Compass, maybe it will call the tool to look up some data in your application. But also under the hood, we have some internal tools that perform retrieval augmented generation, which practically means we have a search engine over our internal documentation that we use to inform the answers generated by the AI to provide more reliable, accurate answers than just the model would be able to provide on its own.
I know that's really important for giving our users the right answers. Can you talk a little bit more about how Atlas Vector Search, and Voyage 4 fit into the architecture of the assistant?
Sure. So we use all of those technologies to power the experience. When we started out building it, we were using MongoDB, Atlas, and just the standard MongoDB database features within Atlas to store all of our conversation data. And we also use Atlas Vector Search to power that retrieval augmented generation aspect of it. And more recently, with the introduction of the Voyage 4 models on Atlas, we've been using that as our embedding models in the retrieval system. And since we switched over to Voyage 4, we've actually seen, believe per our internal evaluation metrics, it's a 10% quality increase just by switching out the previous model that we were using for the Voyage models. So we're able to deliver even more reliable answers to our users.
Love to see that.
With this idea of reliability in mind, how do we communicate through the product design that this is, in fact, a reliable product that our users should trust?
That's a good question. I think when it first went out to the public, people were far more wary of AI 3 and however many years ago. And now people are using AI, especially developers, every day in their workflows. So it's less that people are wary of AI, but wanting to give them trust in our specific assistant. So that's things like helping the user to understand what the assistant can and can't do upfront. It's things like understanding how much information we need to give to the user. So depending on what the assistant is doing, how much do we want to tell them about what's going on behind the scenes? And I know that as we start to think about more complex use cases, we're also thinking about how much control and how much oversight we want to give to the AI assistant and how much we want to let it run autonomously. So there's all these considerations, and I think it really depends on what the assistant is doing. And I think as long as we're giving people control over even the settings for the assistant and what kind of features they want to enable or disable, I think that's how we're going to earn their trust. In addition to all the things that your team is working on, like data security and correct answers.
Yeah, we spend a lot of time thinking about those things, how to ensure that the assistant is not just reliable in the answers that it gives you, but also any data that it touches, especially if it's customer data, is by default just not stored at all, because if it's not stored, there's way less security risk. And if it is, how do we handle it securely, only store the most minimal amount of data, and even that data which we store, we put in a very secure location. So now that we've been working on this for a few years now, like we've kind of cut our teeth in the space, so to speak. What do you think is unique about designing for these generative AI experiences over traditional software products?
Good question. I mean, I think that a lot of designers across the industry and certainly across MongoDB are grappling with the same transition, or have been for a couple years now. I think one of the biggest differences is that you're not designing these user flows where it's like, as a designer what this button will do, and the user has total control of all of the levers and knobs and is really controlling the outcome. It's this more probabilistic thing because AI is probabilistic. And so we're really trying to give users the right amount of information and the right amount of insight to know what to do next and to feel comfortable working with the assistant. So I think similar to, we were talking about trust earlier on, I think it's really thinking about how do we build a system that's flexible for the types of questions that the assistant answers and the actions that the assistant needs to take, and also being really careful taking into consideration, when we need to give users certain controls and information. And I could ask you the same question.
So I think that what is unique about building for these AI experiences that kind of differs from traditional software is the emphasis on evaluation and taking an evaluation-driven approach to development. And by evaluation, I mean having a bunch of input cases that are representative of real things that a user would ask, then piping them through the system and measuring how well the system answers those cases, and using that as sort of the North Star of our product development lifecycle. Because given that we know the system already works pretty well, I think with AI, you can get to a prototype just sort of through vibes and, this feels right. But to make something a production system and a reliable production system over time, you need to take this evaluation-driven approach to make sure that there aren't any regressions, and that when you're adding new features or, say, changing AI models, you can make those changes and just quickly measure whether or not it's working well, as opposed to just playing around with for the vibes, because that really doesn't scale.
Yeah, I've definitely seen the team put a lot of effort and care into making sure that we're answering all the questions we need to. So how has MongoDB made building the assistant easier?
So it definitely has made building the assistant easier. And I'm not just saying that because I work here. So the Atlas data platform with its core database has allowed us to really easily scale the application as our traffic has grown. And it has grown tremendously since we launched, which is nice. And then there's the AI-specific features, namely Atlas Vector Search, which we use for our retrieval system. And then more recently, we have the Voyage AI models built into Atlas. So we use the AI through an API embedded within Atlas to perform retrieval.
So looking ahead, where do you think developer AI assistants go from here?
So I think if we look at how it has evolved over time, we can see where it's going. We started out just doing these natural language question and answers where it wasn't really touching a developer's unique experience or their own data. And that was great a few years ago when the models were more limited. But over the past few years, we know that the models have gotten meaningfully better. They're able to perform these more agentic tasks, we call them, take actions on users' behalf. So right now, the functionality is very read-only. It'll look at the data, tell users about their data, but won't necessarily do anything. So I think the direction which we're moving is having the AI do things agentically on the user's behalf.
Yeah, I agree. I think that that's definitely where we're going from our assistant's perspective. The nature of AI is changing so fast. I was going to say in 6 months, who knows what it'll look like, but probably more like in the next 2 weeks, something could shift and something else exciting could happen. So it's a fun area to be thinking about.
Thank you for listening. It's been a pleasure sharing our
Welcome back. Now please welcome to the stage Pranil Vora of Rivian.
Good afternoon, everybody. My name is Pranil Vora. I lead the team behind the Rivian Assistant at RV Tech. Today I'm going to be walking us through what we built, the memory patterns behind it, and specifically why we built it on top of MongoDB. Before we get started, I wanted to take a quick second to introduce RV Tech. RV Tech is a joint venture between Rivian and Volkswagen Technologies, and our primary focus is to build a shared software platform behind all of the different vehicles that we're manufacturing. We move really, really quickly. We were founded in 2024, and within the first 12 months of us launching the joint venture, we actually built a test vehicle with our zonal architecture migrated to it from Rivian. And more recently, we actually had our first validation prototype that's customer ready, validated in winter testing in March. So what is a software-defined vehicle? Traditional vehicles often have many different computers. There's tons of different computers for different functionalities. And a software-defined vehicle is essentially a mesh that brings all of them together. So this is what allows us to basically update your car as if it was like a phone. So you can get new features to your car just as quickly as you would get to your phone. Why this is really, really incredible is because most legacy companies actually have over 100 different computers in their different vehicles. So you can imagine a specific computer for the windows, a specific computer for the infotainment system, a specific computer for the climate system as well. So the crazy thing is none of these computers actually know about each other, and so there's no way that you can actually update their software very quickly and produce software updates on a monthly cadence. So that's exactly what we're solving with software-defined vehicles. We're able to mesh them all together and incredibly provide customer updates every single month and bring new features to our customers very quickly. The really cool thing is about the Rivian Assistant is it's an incredible testament of exactly this. So Rivian Assistant obviously did not launch with our cars a couple of years ago when we launched all of our vehicles, but we were able to launch Rivian Assistant to every single one of our customer cars a few months ago, including our Gen 1 cars that came out when we first launched the brand as well. So this was really, really cool because you bought a Rivian a couple of years ago, you get another software update, and suddenly your car is incredibly smarter one day.
Today, I'm very excited to announce the Rivian Assistant.
Hey Rivian, clear my schedule.
Okay, I'm deleting all your events for today.
What's on my calendar today?
You have 2 events today. Call with Tim from 2 p.m. to 2:30 p.m. and meet up with Wasim from 3 p.m. to 4 p.m.
Can you move my call with Tim to 5 p.m.?
I've moved your call with Tim to 5 p.m.
Can you send a text message to Wasim and show him the top 3 options from this list? Ask him which one he wants to meet up at, and include my ETA.
Would you like to send a message?
Awesome. Cool. So since we launched the Rivian Assistant, we have received incredible reception for our customers. It was actually the fastest software install that we've ever had in Rivian history. Customers absolutely love the product. In fact, the retention numbers since the first launch are way beyond our targets. And it's really only possible to build a product like this when you have an incredible foundation of data and AI underneath. So that's what I'm going to be talking about today. This is what we like to call Rivian Intelligence. Rivian Intelligence is a fabric of every single touch point that our customers touch with all of the AI agent systems that we have in the background. So what this means is that whether a customer is interfacing with the vehicle voice assistant, with our mobile companion assistant in our application, or our diagnostics and service AI systems, they're able to completely interact with a system that understands who that person is and understands what they really need out of that specific touch point. And the cool part here is that the AI memory system that we've built is powered across this entire architecture, and it powers every single one of those touch points. So something interesting that is particular to our use case is that our vehicles are constantly traveling on the road. So what that means is they are often going out of network, there's dead zones, people are going camping, they're going off-roading. Vehicles essentially might not have connectivity. And what that means is that everything that I just talked about on the previous slide, we really need a way to be able to continue conversational interactions while you're offline. So with the R2, we're super excited to be able to bring a lot of this architecture directly to the embedded hardware on the R2. So similar to the language model that we have in the cloud, similar to the audio models that we host in the cloud, the agentic systems, we distill a version of that down and bring that into the hardware, and that makes it possible to continue your conversations while you're offline. And then also, as you come back online, the system's able to seamlessly sync that. So it's as if nothing ever really happened. The customer doesn't even know if they're offline or online. So what is this entire architecture really buy for the customer, right? This is a use case that I find particularly really cool because it really kind of is a testament to how this product is not just a simple chatbot that we bolted on top of the dash, but really it's deeply integrated into the vehicle, and it truly understands who you are. It understands what's happening in the car when you're speaking to it. So it understands when you say, text my wife my ETA, maybe you're going to dinner, it knows exactly who your wife is. It knows exactly what the navigation system is saying about your ETA, and it's able to form a perfect message about exactly, it's able to draft that message directly with your phone and actually send it to that person as well. So when we built the Rivian Assistant, we thought about memory quite a lot. We thought about the fact that to truly provide a personalized experience, there's going to be a robust system that's needed for memory. And memory brings along a lot of challenges. You have to think about what is it that you want to store, what do you actually want to, what do you not want to store, how long do you want to store those things, and there's a lot of complex logic behind a lot of the different use cases. For example, if you're navigating somewhere, you're setting the climate system, you're using media applications, how do you bring all of that context in at the right time? So our team spends a lot of time thinking about how to bring that context in our agent very intelligently and very efficiently. The cool part is everything aside from that, including the indexes, including the databases, including the vectors, MongoDB runs all of that machinery for us. So we're able to focus on what we do best, building an incredible experience for our customers, while MongoDB helps us scale to our entire fleet of customers. Something specific about our use case is that given that we are in a vehicle, creating agentic memory is a little challenging. There's typically multiple people in a car. There's typically multiple drivers that might own a vehicle. So knowing where to bind that memory to a specific person becomes an important challenge. Second, it's also very important to prioritize different levels of context. So in a vehicle, there are things constantly changing with respect to your navigation system. Things are constantly changing with respect to, are your seat heaters on? What kind of climate is on? And you really want to make sure that you're not going to incorporate stale context or stale memories when your agent is acting on them. So prioritization of the memories and live state is very, very important. And lastly, speed is absolutely important here, because when you're in a vehicle and you want to create a delightful experience that's also safe, voice is really your only interface that you have here. So if voice is the only interface, we can't anticipate having much longer latencies by introducing memory. So it's very, very important that if we're introducing memory, it has to be fast, it has to be quick, and the customer shouldn't really feel like the assistant's taking too long to respond as well. So before I get into the different types of memory, I wanted to do a quick show of hands. Who in the audience remembers what they ate 2 Tuesdays ago? Nobody? Cool. What about, does anybody remember who their childhood's best friend name was? Looks like a lot of people. So brains are kind of what we want to emulate with agent memory, right? So it's not that your brain ran out of space for that lunch. It's actually just that your brain recognized that it's not important to remember that, and it's not important to actually remember that past maybe a couple of days, maybe a week. Really, it's not important information to carry through. But your childhood best friend, your brain has recognized that that's very important. It should be bookmarked for your later recall. So really, brains have really been doing index TTL like our entire lives, and that's exactly what agent memory is all about. So when we think about agent memory, the first one that is very important here is the session state. So when you're in a vehicle, what's actually happening? Everything I talked about regarding the status of the vehicle, what you're doing with the vehicle, your specific configuration, that's all what you want in your working memory when the agent is running, up right in front. Second, this is the obvious one, what is the short-term conversation history? So the actual turns, what most people are familiar with as the human, the tool, the AI grouping, a couple of those you probably put in your context history. You don't want to put too many of them because you're going to use up all your context budget. So 3, this is how you kind of solve for that, your conversation memory. So by doing a rolling summary of what you actually are talking about, you're able to kind of persist the important things of that short-term conversation into a longer-term grouping. So essentially, you don't have to use as many tokens to represent that same amount of information. And number 4 is profile facts. So there are certain types of memories that kind of just need to persist forever. So think about things like maybe you're vegan, maybe you like Italian restaurants, maybe you have an aversion to a certain type of coffee place. These are things that we store that are kind of longer term, and they don't really need to expire per se. And lastly, number 5 is episodic recall. So this is kind of what you can imagine as how do you kind of remember things that might have happened over the course of weeks, months. So maybe you went to an Italian place in Hayes Valley a couple of weeks ago, and you forgot the name. So you can ask, hey, Rivian, where was that place that we went a couple of weeks ago? Let's go there tonight. And being able to pull out those types of memories is super, super important when you're building an assistant that actually feels like it really understands you. So one of the main reasons why we built on top of Mongo is really the flexibility. So there's tons of different agent memory solutions out in the market. There's a dime a dozen. Some of them use complex knowledge graphs. A lot of them are really targeted for generic agent memory use cases, which is great. For certain use cases, those are actually really good. For certain advanced types of use cases that might require them. But they're not always going to be the best use case for what you might be building. And sometimes if you really prefer to have a simplified stack, if you prefer to have more control over the data, if you want to know exactly where your data is, if you want to have good customer transparency about what data you're storing about them, if you want to be able to do deletion about that data, it's really, really important to have direct access to that. And a lot of those types of platforms actually don't offer any of that. So when we looked at building on top of Mongo, it was really, really important that we could control all of the logic around how we're storing and ingesting, storing and retrieving memory. This really allows us to make sure that we have a strong privacy posture. We're able to know exactly what we're storing. We're able to really build custom logic in our agent for how that memory is stored, rather than having to kind of rely on whatever a memory platform might kind of push on us. So all to say, it kind of simplifies a lot of the operations and gives back a lot of the power back to the team to choose how to incorporate memory into the actual use case. So the Mongo CEO earlier this year said this quote, and I really couldn't agree with it more. When you're building an agent, everything about bringing it to production, making it robust, is about the underlying data. It's not always just about the model selection, what you're using the fanciest model. It's about how are you using the data underneath to actually provide a meaningful, personalized experience. And this is what really allows us to, and this is really why we think Mongo is a great choice, because it allows us to do exactly that. Even thinking outside of the vehicle voice assistant use case, documents are actually a really good fit for agent memory in general. Typically, when you launch your agent to production, you're going to have a set of assumptions that you're going to production with. You might think that you need to store things a certain way, but very quickly you're going to get feedback from your customers that the user experience actually needs to be a different way. And you're going to want to adapt that schema. You're going to want to adapt how that looks like in production. You're going to want to push it quickly. You're not going to want to have to deal with things like migrations, things with re-ingestion of the data. You really just want to be able to change your schema as you go. You want to be able to add collections as you go without thinking too much about it and just focusing on what makes your agent special for that use case. So with collections, with the ability to give TTLs to different indexes, you really can control all of that very, very fine-grained with documents, and which is exactly why we chose documents to be our primary store. The cool thing is about using Mongo is that you also get vector search along with it. So in our case, we have tons of different user manuals. We have knowledge bases for different parts of the car. We have so many different variants of our vehicle. So it's super important that we can actually access all of that information, but in a very specific filtered way per agent, per vehicle. And the ability to just put all of this in Mongo, the ability to have it all vectorized there, and then use very, very fine-grained filters for each of our vehicles, for each of our OTA versions, for each of our models, is really, really magical because from the agent's perspective, this is incredibly simple logic now. It's a simple query with a simple group of filters, and it gets exactly the information that it needs very, very quickly. This next part is also incredible because not only can Mongo store your embeddings, but it can also help you. Develop your embeddings as well. So with Voyage, now you can actually generate embeddings and put them directly in Mongo. And the cool thing is you can generate many different kinds of embeddings for the same data and have them right aside each other. So new models come out, you want to use the latest and greatest, get more accuracy. It's very, very easy to switch over to a new embedding space without having to worry about a significant migration or ingestion problem. And this is kind of why I think it's kind of like a one-stop shop to do all of your RAG plus all of your memory without having to worry about multiple different services and different pieces of infrastructure. So something really important is not just when you should store something, but when you should also forget something. Context is only as good as how valid it is at that single moment. So if you're thinking about all of the decisions around how to forget data, how can you think about how to not bring something stale back into context that might actually provide a bad user experience, it's really important to build policies inside of your agent, but then also inside of your collections to ensure that things are expiring at the right time, things are not being accessed or prioritized when your agent is actually bringing them into context. So just as important as ingestion, it's also very important to also forget certain types of memories when you're building a personalized agentic experience. So thinking about everything that we built, there's a couple of things that we took away from taking this to production. One, the layering of the context is incredibly important. In our use case, live context needs to be prioritized. In other use cases, context is still important to layer because there are different things that are important for the agent at different times. So it's incredibly important that in your agent code, you have the right machinery to actually organize that when you're providing it into the context. Otherwise, you'll have agents that are kind of remembering things that they shouldn't be remembering, adjusting behavior based off of that. An agent can take a bad action on a vehicle because it remembered something from a couple of weeks ago. So this is really, really important to get right, and this all lives in your agent code. Second, this is something that we think about on the team a lot. Often the simplest architecture is probably the best architecture. Unless you have an incredibly complex use case that requires some very specific nuanced technology, you really should be trying to use the simplest solution for your problem. And in our case, that means that we don't want to build complex knowledge graphs. We actually can get away with using documents in a very intelligent way, in an optimized way, using summaries where they're needed, and really avoiding the burden of having significantly larger infrastructure to manage and more complexities that we might have to navigate through production systems. And lastly, try to reuse components wherever you can. So in our case, for Mongo, we're able to have our vector search, we're able to have our memory services all in one place. We're able to really just use as little as we can without having to build so many other systems. And this brings back so much engineering time back to us because we get to focus on what we love doing, which is building an incredible customer experience for our users. We don't want to have to worry about tons of different infrastructure that isn't what we necessarily want to do or are the best at. Cool. So when we set out to make the assistant, it was really, really apparent that we had to bring memory into the assistant in a robust way. But I think what we didn't necessarily think about was the idea that it's very, very important to forget memories and incorporate a degree of layering to make sure that the assistant is actually as useful as possible. And that's actually the best thing that you could ever do for your agent, is just focus on the agent code that allows you to make that exact layering for your user in all of the different use cases that matter to them. And lastly, I do want to say we have demos going on in the back for Rivian Assistant. So if anyone is interested in trying out the Rivian Assistant or talking more about memory, we'll be back there later today, and happy to answer any other questions as well. Also, we are hiring if you're interested.
If you have any questions, just raise your hand. I do have a microphone. No pressure.
We got a question in the front.
Coming to you.
Hi. Do you have MongoDB on vehicle? Or, of course, you have in cloud MongoDB, but also, for example, for version 2 vehicle, also MongoDB?
Sorry, it's a little tough to hear you. Do we have what on the vehicle?
MongoDB locally on vehicle.
We don't have MongoDB, but we have, in the new architecture that we have on the R2, we will have AI memory on the vehicle in a simplified manner. But when the vehicles come back online, our idea is that that will sync back up to Mongo so that it's as if the car never went offline.
Any other questions? Raise your hand high. There we go, over here.
Hi, great session. My name's Amanda. You mentioned the 5 different memory types. Which one was the hardest to get right? And which one do you think has provided the most value for use in existing customers?
Very good question. I'll take the second one first. I think in terms of value is interesting because there's value to us as we're providing the product, and then there's value for customers in terms of it actually becoming useful. So I would say in terms of value for us, using conversational memory or summarizing memory is a great way to be more efficient with your tokens. Otherwise, you're just kind of forced to use a much longer conversation history in the agent. In terms of value to customers, I would say the episodic recall and the facts that persist for a longer time, those are the ones that are really going to drive value for customers, because that's when the customers don't really expect maybe it to remember, because they're like, what was that place I went to a couple of weeks ago? And the fact that it can remember that, help them get there, is kind of delightful. And then also, maybe you're in a new area and you're looking for a coffee shop in Tahoe, or you're looking for a restaurant in Tahoe. It knows that maybe you're vegan and you don't like certain types of food, so it'll just start suggesting places that accommodate your preferences somewhere else that you might visit. Yeah.
Any other questions? Scanning the room, looking for hands. Up, one right back over here, stand by. Getting my steps in today.
Just a simple question. How do you differentiate this product from Siri?
How do we differentiate this product from Siri? Yeah. That's a good question. And it's something we actually think about a lot when we're building the product. So there's a lot of assistant products out there, like Siri, ChatGPT, and the challenge with some of these is that they don't understand what's happening in your vehicle when you're in the car. So something that we set out to solve is we wanted an assistant that would be deeply aware of not only your personal context, which some of these other assistants do quite well, but also the vehicle context. And fusing that together to provide really interesting use cases while you're driving is really the focus of the product. And that's where it differentiates itself from other assistants, by really becoming the best co-pilot that you could have while you're in your vehicle.
Any other hands? And a follow-up.
So just a follow-up, how would you make that edge consistent, right? What if Siri later on has a connection with connected cars and whatnot? How do you maintain that edge?
Yeah, I think that goes back to a lot of why we're building software-defined vehicles, where because we literally own the entire stack down to the hardware, every bit of code is written by us. So it would be very difficult for somebody other than us to provide that incredible user experience, because no other assistant would have access to the various types of things that our assistant actually is understanding about the vehicle, as well as the Rivian ecosystem. So think about diagnostics, thinking about service. The same system is able to understand things that are going on in your vehicle, is able to recommend things to do to take care of your vehicle, understand issues with your vehicle, things that really no other assistant will ever be able to kind of tap into in an automotive sense.
We have a question over here.
Hi, thank you again for the talk. My name is Priya. Going on the theme of what he was talking about, I am a big CarPlay user, and one of the things that draws me to using CarPlay over anything else is the fact that I can use some of my iOS apps. So for example, like Spot Angels, which is really great for finding parking in the city. How does Rivian think about these things, and like, is there some pathway to maybe integrating with stuff like that in the future?
Yeah, that's a great question. So part of the Rivian intelligence, if I can go back to it maybe. So part of Rivian intelligence is not just thinking about the context within Rivian, but we're trying to enable as many third-party integrations as we can as well. So what that means is, so first of all, when we launched Rivian Assistant, we launched with a Google Calendar integration. We're very quickly expanding the number of integrations that we're going to enable. So through integrations with these third-party providers, we're planning on bringing the same type of experience for the types of applications that people love using in their cars directly into the ecosystem. So for example, you can go into your Rivian mobile app, you can log into these integrations, and then they become completely aware, and the assistant in your vehicle becomes completely aware of them as well.
Any other hands? All right, well, please put both of your hands together one more time for Pranil Vora. Thank you so much.
Thank you so much.
The next session will begin right here at 4:15. Stay around to learn the latest about our MCP server and Voyage AI. If you are staying, our teams will be coming around to scan your badges.
Digital transformation is something that is going on all around the pharmaceutical industry. We are all working towards the same goal. We produce 50% of the world's insulin, and we serve approximately 40 million patients around the world. Digitalization is very important for Novo Nordisk because we want to improve our efficiency and reach a patient faster. NovoScribe is an automated authoring platform developed internally here. It's based around the principle of structured content and natural language generation, and has delivered a lot of efficiency in document creation and authoring.
In the clinical reporting space, document automation is a big challenge. A major part of our digitalization activities is to increase the quality of the documents we produce and produce them faster so we can get them submitted to authorities as quickly as possible. One of the traditional ways has been the adoption of content component management systems, or CCMSs. These have significant challenges. The reason we chose MongoDB was that it had been used across a number of different industries for a number of years, showing a high degree of success.
Before using MongoDB, we didn't have a real database strategy. So we tried out different things. We obviously experimented with SQL, but we realized very fast that it's not really feasible the way our tool itself works. So once we moved to MongoDB, it became very easy because basically the structure of what we have just perfectly fits the JSON format. We could develop faster. We could spend way less time on how we use our database. As a pharmaceutical company, we have very strict guidelines with regards to data retention, access control, disaster recovery. Using MongoDB Atlas, all of this is taken care of automatically.
Our primary use case has been the clinical study report, which is a comprehensive document that we produce for all of our clinical trials. Previously, it took around 12 weeks to create and a significant amount of resourcing. Now we've managed to go down from 12 weeks to 10 minutes to produce each document.
In the future, we plan to use Novoscribe not only for the clinical study report, but across the value chain in other areas where we plan to leverage generative AI via MongoDB Atlas. What inspires me is to be part of optimizing the processes that deliver digitalization to Novo Nordisk, and by this, being able to deliver medicines faster to patients in need.
We started with a vision. That vision was, can we build a marketplace that makes it easier for insurers and brokers to do business together? If you look at the way the market works at the moment, there's a lot of individual connections. There's a lot of effort that goes into it from a broker perspective of getting the data to the insurer, and for the insurer to be able to make a decision and be able to get that back to a broker in a meaningful time. All of that is slow and complex. So we started from the premise of saying, can we digitize this process so that there is an easy way for brokers to get information into the system, so there is an easy way for that data to traverse into the multiple insurers that it needs to. When you're working in an industry like an insurance, you can't just say something looks like X or something looks like Y. Neuron is a solution that works inside the commercial market. The commercial insurance market is a huge thing. It's not one thing. So that might be ranging from small businesses who just need to insure a vehicle. It might be enormous organizations who need to insure satellites. When you're dealing with that kind of difference between the goods and services that are being dealt with, you can't just assume that there is a single source of data, single types or sets of data that are valuable. Having a lot of flexibility around the tools that we use. We can't just put in a monolith and assume that that's going to work for the next 20 years. This isn't an internal system, it's a client-facing system, and it is a multi-tenanted system. So we're providing access to many, many different clients, both insurers and brokers. That means that we have to be able to flex. We have to be able to change while still giving access to, for example, to older versions of APIs for people who can't move as quickly. So the challenge is always meeting those regulatory requirements wherever they are in the world, and even wherever they are in a given country. If you're in the US, you have multiple different regulations that you have to deal with depending on what state you're in. Meeting those security requirements of your customers' expectation of the data. Also working with the risks, understanding those inherent risks that you're dealing with, and making sure that you are cognizant of and working inside a risk space that you're comfortable. So our strategy has always been to use SaaS technologies wherever we can, because who knows how to run a technology better than the people who've built it. MongoDB itself is pretty unique from a database perspective, because it allows us to store data in that document data store rather than in a relational database. It has the flexibility that we need to deal with all of those different kinds of insurance, those different markets, without having to create a hugely complex, difficult to maintain, difficult to update set of relational databases to solve that problem. If you think you need help in doing some of these implementations, reach out to MongoDB, because our experience is that you get really high quality level of support, you get really good quality direction. They offer that at a reasonable price. And I'm starting to sound a little bit like an advert here, I know that, but genuinely the service that we got from actually asking questions rather than trying to figure it out for ourselves. The difference in the outcomes were stark. Take something that could have taken hours, days, weeks, and you can turn it to something that takes seconds.
Historiquement, donc page jaune, c'était France Télécom, très connu pour les annuaires papier. Mais depuis les années 2000, forcément, avec l'arrivée du numérique, il y a eu le SI qui s'est développé sur Internet. Et donc, au tout départ, la solution, elle était partie sur une solution monolithique. Et forcément, avec le temps, c'est difficile à maintenir. Et il y a eu un changement de stratégie qui s'est opéré vers 2013-2014, où on est passé en architecture microservices. Tout ce qui vient du portail, parce que sous le portail aujourd'hui, on est à peu près à autour de 40 millions de requêtes par mois, donc ça est au classement WebPerf des 50 médias les plus visités en France. On est 14e au niveau perf. Alors au tout début, quand on avait passé l'architecture microservices, on était toujours on-prem, on avait un data center là où on travaillait, dans le local. Et ensuite, il y a eu une autre révolution qui arrivait plus tard avec le passage dans le cloud. Donc le choix de notre côté s'est porté sur GCP. Et à ce moment-là, on en a profité également pour migrer les bases de données Mongo qu'on avait on-prem, toujours dans le data center. C'est là qu'on est basculé vers Mongo Atlas.
Ok.
Donc, parce que il y avait des contraintes toujours de maintenance des VM, des montées de version d'OS et tout ce qui est autour. On n'avait jamais le temps de le faire, comme souvent.
Le maintien en condition opérationnelle, c'est pas ce qui fait, ce qui soulève les foules. Hein.
Comme il n'y a pas que Mongo, il y a plein d'autres choses, donc il faut toujours prioriser et c'est toujours, c'est jamais facile. Et du coup, on était, je crois, un des premiers, il me semble, à basculer vers Mongo Atlas. Je crois que ça s'est fait en 2019, il me semble.
Ok. Puis avant le Covid,
oui,
bien.
C'est ça. Tout à fait. Ça faisait moins de ça à gérer. Tout était parti dans le cloud. C'était bon. Voilà. Donc, et puis après, du coup, on a mis en place Terraform pour faire le suivi des infrastructures, de l'infra. Et donc sur Terraform, ça nous facilite avec Mongo Atlas en fait. Et on a juste à mettre à jour des configurations, d'appliquer les commandes et ça se met à jour automatiquement. C'est un peu la magie Mongo Atlas. Et tout ça sans interruption de service. Alors il y a plusieurs bases de données. Il y a déjà toutes les bases tous les professionnels déjà sont stockés dans Mongo. Ça représente 4 millions de pros.
Quand même.
Avec beaucoup de diversité au niveau de la data, parce que forcément un médecin, un plombier ou toute autre activité, c'est pas du tout les mêmes choses qu'on affiche. Il y a cette partie-là, les pros, donc c'est ça. Et c'est sur ces données-là aussi qu'il y a de la recherche qui est faite. Alors aujourd'hui, c'est encore l'Elasticsearch sur cette partie. Mais sinon, les données qu'on affiche réellement, elles viennent de Mongo. À côté de ça, on a toute la partie contribution des utilisateurs, création de comptes, dépôt d'avis, dépôt de photos. Il y a un autre sujet où c'est on a une chaîne d'intégration continue aujourd'hui. Donc on a plusieurs phases pour valider avant que le module aille jusqu'en prod. Et il y a une partie test système, donc pour tous les tests qui sont joués automatiquement. Donc là, du coup, avant on était basé sur Elasticsearch, une stack qui était assez compliquée à maintenir. Et du coup là, on a basculé sur pareil, Mongo Search pour faire cette recherche de données. Et du coup, tout est maintenant stocké au niveau de Mongo. On n'a plus à avoir une infrastructure élastique à côté à maintenir. C'était une volonté de supprimer quelques modules qu'on avait chez nous à maintenir, et puis pour aussi des économies à faire, et puis être plus efficace pour aller plus vite, parce que du coup l'indexation se fait automatiquement, il n'y a plus d'étapes intermédiaires pour pouvoir faire la recherche. Et après moi, dans un autre contexte, sur des traitements asynchrones, qu'on gère chaque étape d'un traitement asynchrone. Auparavant, on utilisait Cassandra, qui était très complexe et qui répondait pas du tout à notre besoin, qu'on avait déjà migré dans Mongo, mais on utilisait encore le système d'index sur les collections. Et là, avec la migration, on utilisait Rabbit, on est passé sur du PubSub, et on en a profité en même temps pour changer la méthode, pour rechercher, faire le suivi des traitements. Et après, au niveau des index, il y a un outil dans MongoAtlas en anglais, Query Insight, là, qui permet de voir les requêtes qui sont potentiellement mal indexées, ce genre de choses, sur lesquelles on peut revenir et améliorer.
D'accord, et affiner.
Voilà.
As AI applications have gone from simple chatbots to long-running AI agents, prompt engineering has evolved into context engineering, the art of optimizing what goes into the LLM's context window. Today, we are talking about instruction-following re-rankers and how you can use them as a context engineering tool. But first, let's talk about re-rankers. Re-rankers are often used as the second stage in a two-stage retrieval system. In the first stage, a search algorithm like vector search is used to produce an initial set of candidates. Then, a re-ranker scores each query document pair and reorders the results by relevance. Voyage AI's instruction-following re-rankers take this a step further by allowing you to guide the re-ranking process by providing explicit instructions on what information to prioritize alongside the query. The re-ranker then uses these instructions to adjust the relevance scores and document ordering accordingly. Let's look at a few scenarios where instruction-following re-rankers can help. Different domains and industries operate under implicit rules that shape what information matters most. For example, in healthcare, peer-reviewed clinical trials carry more weight than general medical websites or community forums. But users rarely specify these rules in their queries. Enter instruction-following re-rankers. All you need is to pull in any metadata needed for re-ranking into the documents passed to the re-ranker. So say you're building a RAG-based virtual assistant for a healthcare provider, and the documents in your knowledge base look like this, where the text field contains the content of a web page and the metadata object contains the source and year of publication. To prioritize certain sources over others during the re-ranking process, you'll first need to pull in the relevant metadata into your documents like so. You can then specify the priority order of the information sources in your re-ranking instructions. Finally, all you need to do is prepend the instructions to the query so the re-ranker can use them during re-ranking. Let's look at the re-ranking results with and without instruction following for a sample query. Say the user asks how to treat migraines. With instruction following, the re-ranker prioritizes information from medical journals, whereas without them, it prioritizes anecdotal experiences and general advice over clinical evidence. Let's look at another scenario. Oftentimes, AI applications have a single overarching purpose. For example, documentation assistance, customer support, or coding assistance. But the types of queries users can ask can span a broad range of topics and complexity. In this case, you can first use an LLM to categorize the query and then use different re-ranking instructions based on that categorization. Let's say you're building a documentation assistant. You can first categorize the incoming queries as conceptual, implementation, or troubleshooting related, and prioritize different types of documentation for each. Long-term memory is a critical component for AI systems to maintain consistency and coherence over time. But as they accumulate more memories, they need a way to dynamically retrieve only those that are most relevant in the context of the current conversation. Semantic search is a common technique for memory retrieval, but it treats all memories as equal. An instruction-following re-ranker on top of semantic search can help prioritize memories based on factors beyond just semantic similarity. Say you're building a travel assistant agent that helps users make hotel bookings, restaurant reservations, and so on. Let's assume that the agent persists the user's travel, dietary, and budget preferences to a long-term memory store like so. When retrieving memories post-semantic search in the re-ranking stage, you can ask the re-ranker to prioritize the user's most recent booking patterns and any dietary restrictions. If you'd like to try out our re-rankers, head over to your MongoDB Atlas cluster and grab an API key for the Atlas Embedding and Re-ranking API. You can do so from right here. The link to the code and a tutorial on instruction-following re-rankers is linked in the description. Thanks for watching.
Experimenting with Gen AI is the easy part.
The hard part is moving past the wow factor to deliver results that are actually reliable, secure, and meaningful is the defining challenge for today's financial institutions. In the next few minutes, we're going to break down the 3 architectural pillars: context, memory, and governance, that turn a generic LLM into a powerful enterprise differentiator. We will show you why these 3 pillars matter, how they can be implemented effectively, and what this looks like in a real-world example in the financial services industry. Pillar number 1, context. An AI is only as smart as the data it can see. In finance, early AI focused on predictive analytics, assessing credit risk, detecting fraud, forecasting market shifts, and predicting customer churn. Today, GenAI takes it a step further by synthesizing structured and unstructured data. The competitive advantage here comes from feeding operational data to your AI. By understanding user's role, department, and query context, AI can do more. With context, AI can dynamically synthesize info, personalize recommendations, and make critical alerts faster than before. From smart document intelligence to improve onboarding new prospective customers to agentic AI-powered investment portfolio recommendations, unstructured data plays a critical role in today's processes and can be the roadblocker or the thing that boosts innovative solutions and stepping up into the future of the solutions industries offer. Rich context ensures that AI delivers accurate and actionable answers. Without it, responses can become delusional or irrelevant to the original prompt. Pillar number 2, memory. LLMs are essentially stateless. They process knowledge in the moment, then forget. Memory is what allows an AI to learn from interactions and track emerging patterns in real time. For example, agentic AI in finance relies on memory to continuously monitor markets, detect emergent fraud patterns, and adapt workflows in real time. This is where MongoDB Atlas is a great example of memory at play. The document model lets you store everything, from regulatory logs to multimedia, in one place. Vector embeddings enable semantic search and contextual retrieval. AI partners can remember past interactions, link new data to historical context, and deliver intelligent, proactive guidance. Memory transforms AI from a reactive tool to a trusted, goal-driven partner. Pillar number 3, governance. This is the guardrail between a successful deployment and a massive liability, especially in financial services. With strong governance, AI runs in a controlled environment where sensitive data stays protected, access is restricted, and every action is traceable. Which is why many banks favor small, tightly governed language models over more powerful but riskier options. You need governance built directly into your data workflow. When you combine rich context with secure access to data, you gain transparency into data lineage and reasoning and full auditability. Your AI needs to show its work following emerging Know Your Agent expectations, so you can track which data was used, what outputs were generated, and why a decision was made, giving compliance teams the explainability they need to trust the results, and provide transparency to the final users and regulators. Let's see how these 3 pillars look in a real-world high-stakes environment. Imagine a global bank that doesn't just store documents but actually understands them in real time. Most institutions are held back by what we call invisible friction. It's the thousands of hours lost sifting through emails, folders, or manually extracting data from complex contracts. When simple questions require human review, workflows stall. Risk exposure climbs, and your most talented people become data hunters instead of innovators. But it doesn't have to be that way. We're seeing a shift towards document intelligence, where AI transforms that operational friction into true actionable insights. Banks are moving beyond simple automation to what's called agentic AI. This isn't just about reading text, it's about making your data AI ready. Whether it's streamlining client onboarding, automating investment research, or accelerating loan origination, the goal is the same. This shifts the workflow from manual verification to autonomous investigation. Instead of just processing data, you're deploying agents capable of reasoning through complex compliance patterns in seconds. This doesn't replace the expert, it empowers them. The agent handles the high-volume analysis to surface high-fidelity insights, allowing the human in the loop to focus their expertise on the most critical, high-stakes decisions. It's about achieving machine-scale precision while maintaining human-led oversight and staying ahead of the speed of the market. Let's take another example, financial crime mitigation. Today, many institutions are held back by the exponential costs of false positives. the legacy systems that struggle to map complex money laundering networks. Using MongoDB vector search, you can capture and analyze behavior patterns to stop fraud before it scales, rather than just reacting to it. And with chain streams, you can propagate updates to your risk models in real time. This ensures your production decisions always reflect the most current logic. This is how you transform a high-cost necessity into a streamlined, intelligent engine for growth. Synthesizing these pillars, context, memory, and governance, represents a move towards a more mature AI strategy in the financial sector. First, context is about the integrity of the data ingestion, its ability to pull from diverse data types and sources so that the model has the necessary background to provide accurate, industry-specific responses. Second, the memory provides the persistence required for multi-step tasks, but it also does more than simply retain history. In MongoDB, memory becomes a shared single source of truth, where insights can be stored once and reused across agents, so what one agent learns can inform the next. The memory then becomes context for future decisions, creating a continuous loop between context and memory. Together, they create the foundation for governance, where every action can be more consistent, traceable, and trustworthy. Finally, governance is becoming the cornerstone of deployment, with emerging frameworks like Know Your Agent, and the focus is on maintaining a clear record of data inputs and model outputs to ensure full explainability behind every automated decision. By solving for context, governance, and memory, organizations can bridge the gap between experimental AI and stable enterprise-grade production environment. If you're ready to build an AI that's context-aware and secure, explore the resources linked in the description. And don't forget to leave your comments below on what you'd like to learn next.
Neil, it's great to meet you. What is NPAL?
NPAL is in the business for sustainability and green energy, with about 80 to 85,000 systems in the field containing solar PV, batteries, wall boxes, and now also expanding into the heat pump market with about 3,000 heat pumps in the field already. Very, very fast growing.
I can imagine out there in the field, there's a lot of complex integrations with a very rapidly evolving electricity market. But from your position as a chief architect, probably also quite a lot happening, right? There's more and more devices out there. There's a lot of data coming in. What is that data? Where does it go? And what do you do with it?
To make it very simple, we get a lot of data from all these products that we're offering to the customer. We have to ingest all of that, make it available for the customer to basically see what's happening at his site. How much energy do I produce? How well is my battery charged? Is my car charging right now? And also give him control over these assets, like start charging my car now, for example.
Because your proposition is evolving and because NPAL is growing quite fast, I imagine the sort of data schema needs to be quite flexible as well, right? I presume a traditional SQL database would be problematic. So how are you collecting this data and how are you storing it?
How it is currently is that we are storing incoming data in a blob storage file that is basically accumulating all of these data points for a customer per day, which is very easy to query, so the user experience is quite fast, but it makes it a bit harder to do aggregations or to prepare certain things for our customer service to have it available early. So we now are in a transformation phase where we want to take all of these data streams and make them a bit more universal and make them available to our streamlined teams, and then go with a data cooling approach to have things available in data warehouses for like aggregation and historic evaluation.
And presumably this data coming from the devices, you'd consider that time series data, would you?
That is time series data, correct.
Okay, and you are using MongoDB as a sort of hot storage database for that?
Yes, and the approach that we're now going to implement, we basically get all of these time series data, lots of timestamps, lots of sensor values, and we are transforming this into a standardized format where we basically just define how something should look like in terms of what kind of sensor are we talking about. Put all of that in our time series database to have it available for now for 30 days, but we also think about increasing this depending on the usage. And after that time, it will go into a data lake. The very positive part of this is that querying the database with MongoDB does not cost additional money. It's very easy to scope the costs, very easy to scale, and the queries are basically for free.
How much of your IT environment is in the cloud? How much of it is on premises?
That's a very good question. We do have quite a significantly sized cloud environment as NPAL as a whole, but also in the IoT department. But we also have a dedicated team for system integration, which is closer to the hardware part.
Yeah.
There is this NPAL 1 box that is controlling all of the hardware pieces, like the wall box, the battery, the inverter. They basically make sure that things can talk to each other, which is a way different world with Modbus over TCP or EE-bus. So we do have basically a contract between the hardware team and the cloud team so the communication can work.
How do you interconnect the two?
Currently, two methods. One method is MQTT, which we onboard for newer use cases, for example, like VPP, that needs a higher frequency of data transmission. And we still have the IoT Hub, which is a Microsoft product in Azure that is connecting the more general use cases, but we want to slowly migrate away. We were on the lookout for time series databases and got in contact with at least 2 different companies of consultants. And the MongoDB consultancy was the best with quite a lot of distance to the other people. We had some very weird technical questions that you usually don't expect, because storage is one of the cost drivers, because there's just so much data.
Yeah.
We asked weird questions like, how would we expect compression to work? How does the compression algorithm go? How can we project how much data we can save by compressing our schemas? How should a schema look like? Or just simply, okay, if we do this, how big would the index be and does it fit into memory, right? Because that needs to be fast. And we got answers to all of that, actually, which impressed us quite a lot. MongoDB was very open for in-person workshops where our contacts, Andre and Philip, basically visited us on the headquarter office in Berlin. And we had a workshop together. And it was great actually answering how the index is built and how it's fitting into memory. Working with MongoDB Atlas is very pleasant actually. The Terraform integration is great, so all of your projects can live as code. And the DevOps team made it very accessible for devs. So whenever you have to set up a new project, you just contribute to a repository, they review it, and if it's merged, your project is up and running in like 10 to 15 minutes. That's very pleasant because it makes testing out things very, very easy. On the service part, whenever you need something, you can either configure this through this repository offered by the DevOps teams, or you can just go through Atlas and try things out. For example, if you want to just play around a bit, you can open a playground cluster, load the sample data set, which is available, and then, for example, try out Atlas Search to see how it behaves for you. And sharding in general is a pain, usually. It's very easy with MongoDB. For the schema, finding a schema that works can be very challenging, but MongoDB is always very open to do design reviews. So if you have questions or if you are in doubt that your schema is fine, you can always hook them in, basically explain your use case, show the schema, and get something out of it, like an improved schema or like a way forward at least.
That sounds genuinely really helpful.
That is very helpful, especially if your team still has to grow skills in the particular technology.
Some people might just say, this is pretty crazy. Why don't you just use a managed service in the cloud, right? Why is your group not doing that?
At the beginning, everyone was like laughing at us. And now they take us much more serious.
Richard, could you tell us what Stackit is?
So Stackit was till the 1st of September this year, 2024, part of the Schwarz IT. And Schwarz IT is the monopolist IT service provider for the whole Schwarz group. And they are providing from data center capacity, hardware, to the operating system, backup solutions, databases, up to SAP systems, up to operations in the cloud, everything that's needed for all the divisions inside of the Schwarz group. And now external partners are able to use our services inside of Stackit. The next question maybe will be, why does a retailer create their own cloud? And with that, we have to go back to the point of sovereignty. For us, it's important to know who has access to our data. We want to ensure that only we are able to operate and to know who is accessing our data. Independence is a pretty important part in the Schwarz Group. We want to be sovereign. We don't want to rely on other hyperscalers, because at the beginning they give you cheap prices, but after you have moved a significant workload on their clouds, the way out is pretty challenging. But on the other hand, the cloud vendor, that hyperscaler, is able to define your prices.
Let's lift the lid a little bit on that cloud. I mean, you mentioned at one point in your career you were a DBA, for example, and there's terabytes of data that's coming in from your internal customers. What does this cloud environment look like? What kind of platforms are you using? What kind of databases? Perhaps you could give me a little top-level overview of the environment.
In general, we are dividing at Stackit into two areas of databases: partner databases and our homemade databases that we have developed and produced by our own. So, for example, a homemade database is, of course, the MongoDB Flex or PostgreSQL Flex and our newest database type, SQL Server. And besides that, we have also partner databases like MariaDB. And customers are able to choose their databases. Our homemade databases, they are created on Kubernetes, and everything runs on our OpenStack environment. We have several big topics already running on MongoDB, and it's growing. And one example is our automated ordering of food for the Lidl stores. So every store has their opening and closing times. And a Lidl store has like 2,000 or 3,000 different units of stuff that they are selling in the stores. And during the night, inside of Stackit, we are calculating how much sausages we have to provide to that store, to this store, and everything. And this runs for 11,500 stores parallel, and logistics has to execute what is proposed. So we have really a short time where my colleagues from Autodispo are able to calculate the data. And so they need to have a reliable and performant environment. And this is what we are providing them with MongoDB. 2 years ago, I was collecting feedback about how is your experience inside of the Schwarz IT with MongoDB, and our developers to have experience with Oracle, with Postgre, with SQL Server, with different types of database technologies. And the answer of them was they love MongoDB because they never had any trouble with that. And so far, since that time, I didn't have any bad feedback. And if I don't get bad feedback, I'm good to sleep and have a silent night. Yeah. MongoDB is so easy. I'm pretty sure I could teach it to my smaller son, he's 8 years old, why to use MongoDB. Because MongoDB gives with flexibility everything that you need. In the morning you enter your company, you have the idea to create an application and you think this is the best application ever. And then you start to think about, okay, what do I need? And I need one more field and I have to exchange this field and everything. Everything is flexible inside of MongoDB. If you do it on a relational database, you have to think about, okay, I have that table, these columns. Oh, I need another table. I have to get connected them. Oh, when my data is growing, I need more indexes. Of course, MongoDB needs also indexes, but it's much easier for the customer. And you are not in that tight setup like relational databases. And this gives you really the flexibility by building your application in a fast way.
Here's a take you won't hear at most energy industry conferences. The reason your platform modernization keeps slipping into year 3 isn't that the workloads are too hard. It's that the industry has spent a decade convinced you need a different specialized database for every workload. A time series store for telemetry, a relational database for trades, Kafka for events, a separate vector database for the AI assistant everyone now wants, a warehouse on the side for analytics. Each one was a reasonable choice when it was added. Together, they're the reason your roadmap looks like the way it does. So for the next few minutes, I want to walk you through what the operational data layer for an IPP actually needs to do, and why the simplest answer might be one platform doing the work of 6. The energy business has changed shape. Markets settle every 15 minutes. Regulators ask questions that look 5 years back. And every trading desk and control room now wants AI that reasons over live data and policy in the same breath. 3 things are going to make or break a modern IPP platform: how you consolidate the stack, how you build compliance into the architecture, and how you set the foundation for production AI. Let's take them in order. Start with consolidation, because everything else sits on top of it. Look at the left side of this diagram. SCADA systems on wind, solar, hydro, gas, batteries, biomass, forecast providers, price feeds from ENSOE, EPEX Spot, EEX, the trading app itself producing trades and capacity allocations. All of that flows through an ingestion layer into MongoDB Atlas. And here's the thing that makes this possible. The document model is polymorphic. One collection holds events of completely different shapes: a meter reading from a wind turbine, a forecast revision, a price tick from Apex, a trade execution. They all live in the same place, each carrying its own structure, without forcing the business into one rigid schema. That polymorphism is what kills the case for a separate document store, a separate event store, and a separate analytics store. They were 3 things because the database forced them to be 3 things. With the right model, they're one. Zooming into the ingestion side, telemetry from every asset class arrives through MQTT brokers or Kafka topics. It hits Atlas's stream processor, which lets you filter, enrich, and aggregate in flight, and then lands in a time series collection. Time series collections are a specialized storage engine inside the same database. You get up to 10 times compression compared to a generic collection, automatic bucketing, and query performance tuned for how telemetry actually gets access. A 7-day TTL on the raw stream keeps the hot working set lean, while everything you need for replay sits permanently in the event store downstream. The business effect is direct. Fewer systems to license, fewer to operate, a smaller platform team running a trading-grade data layer, and one query language across operational data, analytics, search, and vector retrieval. Second piece, compliance by design. European energy regulation is specific and getting more demanding. REMIT requires 5-year retention of every order and trade. The electricity balancing guideline requires reconstructible evidence of every 15-minute imbalance settlement period. A CRUD database fails this test. An update statement overrides the previous value. A meter correction replaces the original reading. By the time a regulator asks you what the state of a contract was at 2 p.m. on December 15th, the answer is forensic. The pattern that solves this is CQRS with event sourcing. Every state change becomes a new immutable document in the event store. Nothing is updated in place. You reconstruct state at any point in history by replaying events in version order, applying a fault function to the event log. The audit trail is in a separate system. You keep in sync with the operational one. The audit trail is the operational one. This is where it gets interesting. Once your event store is the source of truth, MongoDB change streams turn it into a real-time event notification system. Anything that writes to the store immediately becomes available downstream. A trading dashboard updates over WebSockets. An alert system fires when a position gap appears. An ETRM system reads the same events through a Kafka connector. The pattern is headless. You keep your data, you avoid vendor lock-in on the systems consuming it. Imagine a TSO disputes a settlement. A BRP claims a meter correction was applied late. With event sourcing, you replay the events for that portfolio in version order. You see the original reading and the corrections side by side, and you reconstruct the exact position the system held when the dispute started. The original incorrect settlement isn't erased. It sits in the log alongside the correction, with metadata pointing at what was corrected and why. Dispute resolution moves from week of reconciliation to a point-in-time query. Compliance stops being a separate subsystem. It becomes a property of the right path. Third, production-grade AI on the same foundation. The use cases the industry is scoping right now are concrete. A trading copilot that reads portfolio state, market prices, and regulatory text together. A compliance copilot that investigates disputes by replaying event streams against the applicable regulation. What separates a working production agent from a demo is where the data lives. An agent that calls out a separate vector database, a separate document store, and a separate conversation memory service spends most of its latency budget on network hubs, and most of the platform's team's time keeping those systems in sync. Atlas collapses all of that. vector search, hybrid search, time series, operational data, agent memory, and tool results all live in the same cluster. The retrieval layer runs hybrid search, semantic similarity through Atlas Vector Search, combined with keyword matching through Atlas Search.
Our session on building agents with MongoDB MCP will begin in 5 minutes. Please find your seats. Our next session is about to begin. Please take your seats and silence your phones. Our next session is Building Agents That Work for You with the MongoDB MCP server. Now, please welcome to the stage Senior Product Manager Gaurab Aryal.
Hi everyone, I'm Gaurab. I'm a Senior Product Manager here at MongoDB, and I work on curating AI Builder experiences for you. For the next stretch, we're going to talk about how MongoDB fits into the way that you're actually building today, with AI agents working right alongside you. A quick roadmap for this session. We'll do a brief MCP primer, then we'll look at where MongoDB MCP server stands today, and then we'll have an exciting announcement of our remote MCP server and marketplace plugins across Frontier Labs. Then I'll invite my colleague Apoorva on stage for a couple of live demos. So what is MCP? MCP stands for Model Context Protocol, which is one standard way to connect AI applications to the tools and data that they need. Anthropic launched it back in November 2024, and it is now backed by OpenAI, Google, xAI, and basically the whole ecosystem. You can think of MCP like this. On the left are your AI applications. And these are things like chat interfaces, programmatic agents, IDEs, etc. On the right are your data sources. These are your tools, such as MongoDB, your file system, Git, Slack, Notion, etc. Before MCP, every one of those connections was a custom integration. MCP is the standard in the middle that is one protocol, which is bidirectional, so any client can talk to any tool. And MongoDB is one of those tools. Back in May, we shipped the MongoDB local MCP server, and it truly has been a great product. It is one of the fastest growing developer tools we've ever shipped, with tens of thousands of monthly active developers, and we are excited to continue building on that success. So here's what the MongoDB MCP server does specifically. Think of it just like the way we framed MCP earlier. A client on one side, MongoDB on the other. Except the server actually gives you two surfaces to work with. First is your data plane, where you can directly talk to your data. And this means you can do things like query collections, explore schema, manage indexes, all in plain English, and all of it from any MCP-compatible client. And the second is the Atlas control plane. The same server ships with Atlas tools, so you can manage Atlas itself. You can do things like spin up and configure clusters, manage users and access, check on performance, all through the same natural language interface. So it is not just chat with your database, it is talk to your data and operate the platform it runs on from wherever you're already building. And here's what you tell us you love about the local MCP server today. And I would like to highlight 3 things in particular. First is you get to talk to your data. The distance between, I wonder, and an answer went from minutes to seconds. And that could sound small until you're doing it 50 times a day, which accumulates a lot. Second is it takes minutes to your first query. One command in any MCP-compatible client, and you're connected whether you're talking to a local MongoDB cluster, a development cluster, or your production Atlas cluster. And third is no matter where your team builds, whether it is Claude, ChatGPT, Cursor, the server works there. You don't adopt a new tool, your tools adopt MongoDB. And this has been great, but today it gets even better. Today, I'm excited to announce that the MongoDB Atlas Managed MCP Server, which is our remote MCP server, is generally available. This means it includes everything you love about the local MCP server, but now Atlas hosts it for you. This means you connect from the tools you already use without having to run it yourself. So what do you actually get with the Managed MCP server? And there are 4 things I would like to highlight. First is there's nothing to host. Atlas runs the server for you. That means there's no local process, and there's no deployment that you need to babysit. The second is one-click user-delegated authorization. You authorize straight from your AI client with OAuth scoped exactly to what you're allowed to touch. Read-only stays read-only, and the agent literally cannot exceed your permissions. And the third is service accounts for agents, which is one of my favorite ones. For headless and multi-agent workloads, you get granular programmatic auth built just for that world. And lastly, it is secure and auditable. Actions are attributed to a specific user or an agent, and it's logged. So what you can see, so you can trace it back to exactly who did what. And you can use it today with the agent harnesses you already prefer. At launch, we've got remote MCP plugins across the frontier AI marketplaces, and honestly, any client that speaks MCP. And with that, I would like to invite my colleague Apoorva Joshi to stage to make this real and do some demos.
Hello, hello. OK, you hear me. Hello.
OK.
OK. OK. Hi, everyone. I'm Apoorva from our developer relations team, and I'm really excited to show you everything you can build with the MongoDB Atlas Managed MCP Server. We are going to do this live, folks, for the most part, so please pray for me. All right, so let's get started. Our first demo shows an incident triage scenario. Let's say we work at a payments company like Stripe, and our payments infrastructure runs on MongoDB. We process billions of dollars every single day, and our customers and their end users have come to expect payments to be processed quickly every single time. But sometimes things just happen, right? But we also have AI now, so there's really no excuse for incident response or anything really to be taking forever. So we are going to create an incident triage agent using ChatGPT and MongoDB's managed MCP server to help our team resolve issues faster. And we can build these workflow automations right from within ChatGPT. But first, we want to show you how easy it is to connect our managed MCP server to your favorite AI tools. So let's get started. So I'm in the ChatGPT web app. I'm going to go to plugins here and search for MongoDB. Oh, user error. There's our MongoDB Atlas plugin. Let's click on that.
Awesome. One quick note, the MongoDB Atlas plugin not only allows you to interact with Atlas via MCP, but it also comes with all of our agent skills. So agents can build applications with MongoDB using our best practices.
That's right. So let's go ahead and install that plugin. That should take me to the Atlas authorization page. There we go. And all I need to do here is hit this little authorize button, and that's it. ChatGPT can now access my Atlas projects and clusters on my behalf with only the permissions that I have.
One neat thing I hope you noticed is that you didn't have to configure any credentials in ChatGPT. You just logged in and your Atlas account and everything flowed right from there.
So now I can start creating my incident response or triage agent from right within ChatGPT. I've already started setting it up. So right now, I've set it up for alerts to come into the agent via the API. This is ChatGPT's Workspace Agents API. And then you can start triaging those alerts right from within ChatGPT. I'm in the web app. You could also have it monitor a Slack channel for on-call Slack channel for alerts. But for now, let's just work through the alerts right here. I've also given the agent pretty detailed incident triage instructions in the system prompt. And all that's left for me to do now is to connect our managed MCP plugin to this agent. And we just installed the plugin, right? So it shows up right here. Let's click on that and hit add. And then you have some additional configuration options here as well. So since this is our production cluster, I've configured it to ask before performing any write actions. So here you can see I'm only allowing read actions by default.
I like that additional human in the loop layer on top of Atlas permissions.
Yeah, OK. So our agent is ready. Let's go hit update, and then go see what happens when an incident hits.
Awesome. Let's say it's Cyber Monday, and we're seeing payment timeouts across the platform. The backend pulls MongoDB for payment status, and the queries are taking too long, and ultimately payments time out and fail. An incident gets reported and automatically triggers our triage agent. Let's see what it does.
OK, so let's see. There we go. The alert came in via the API. What's it telling us? It says US West 2 is seeing payment timeouts and looks like it's a high priority incident since it's affecting about 18% of the transactions on our platform. Let's see what our triage agent is up to. OK, so it's first using the MongoDB Atlas plugin to see what Atlas projects and clusters it has access to. And in the system prompt for the agent, I asked it to first use diagnostic tools like the Performance Advisor and look for any open Atlas alerts, because those are typically the places most likely to surface anomalous activity.
That's cool. Performance Advisor is one of my favorite things on Atlas, as it monitors queries, flags slow ones, and suggests indexes and schema changes to improve query performance.
OK, so let's go ahead and look at the report it gave us. So it looks like the payments collection has a missing index, meaning each query is scanning through an entire collection, which is why our queries are eventually timing out. The Performance Advisor is recommending a compound index on the session ID and status fields, so queries can only scan relevant records instead of the entire collection.
And something to note is it didn't go ahead and create the index because we configured it to ask for approval for write actions earlier.
That's right. OK, let's look at the recommendation. Quick double check. Seems pretty reasonable, right? OK.
I would say so, yeah.
Yeah. So go ahead. Let's go ahead and create that index. So first thing it's doing is establishing a connection to the cluster, and then you see the minute it gets to the create index tool, which is a write action, it's asking for approval. Let's go hit approve and see what it does. So it now runs the create index tool, and it also verifies that the index was actually created. Looks like it was. So now let's go see if it actually fixed our timeouts. So let's submit a payment again. So notice that the payment, like the queries have gone from taking over 2 seconds to just a few milliseconds, and our payments are going through the platform again. So,
yay. Great job.
Thank you.
Developers today are spending most of their time in AI tools. Being able to connect these tools directly to Atlas means that you can offload large chunks of your operational work to your agents. And this will free up your team for creative, high judgment tasks that actually needs humans. What we just saw was how to use our managed MCP server to supercharge your own productivity and your team's workflows. Now, for our second demo, let's look at the other side, which is embedding our MCP server into products you actually use and ship to your users. For that, you typically build programmatic agents that your users can interact with within your product, using frameworks like LangGraph, Maastra, etc. Apoorva, shall we?
Let's do it. OK, but now for this one, let's say we are developers at an e-commerce platform like Shopify. We've built an agent into our inventory management platform that is used by millions of business owners to manage their store's inventory. So the agent we built, what it does is it continuously monitors their shop's inventory, which is stored in MongoDB Atlas, alerts them when items in the store are running low, recommends suppliers to reorder from, and also places purchase orders on the shop owner's behalf.
Programmatic agents like this one authenticate to Atlas using scope service account. You define exactly what the service account can access, and at runtime, those credentials are exchanged for a short-lived access token. The agent only ever has permissions you have explicitly granted and nothing more.
OK, let's go ahead and trigger an inventory sweep for one of the stores on our Shopify platform. I went with a specialty coffee roaster, but really it's just me manifesting my dream of owning a coffee shop someday.
That's great.
OK, so during the sweep, let's see what it does. So it's using tools in our MCP server to first list out collections that it has access to. Then it's running a bunch of get schema calls to understand the schemas of the documents in these collections. Then you can see here it has generated and ran an aggregation pipeline against the products collection to figure out how much of each product is being used every day in the shop. It also queries the suppliers collection for the shop to understand what suppliers the shop typically orders from. And finally, a query against the purchase orders collection to check if there are any open orders. We don't want to be placing repeat orders. And then finally, based on all that information, it finds out that the shop is going to run out of valve bags, which I learned are used to package coffee beans. So what it's going to do is send an alert to the shop owner, and it also logs it to a MongoDB collection, once again, using the insert mini tool in our MCP server, and it waits for the shop owner to decide next steps. And the agent did all of this on its own in the background while the shop owner was sitting on their patio drinking a chilled cold brew.
That's actually fire. Want to quickly show us what's happening under the hood there?
Yes. So I've used LangGraph to orchestrate the agent end-to-end, and specifically the LangChain MCP adapters library to connect the agent to the managed MCP server. So first, I'm creating an MCP client to connect to the server. Then I'm getting the list of tools available in the server. Our server returns about 41 tools, including things like cluster management and performance monitoring tools, but this agent doesn't really need those. So I've done this neat little thing of limiting the list of tools that we pass on to the LLM to just the data management and discovery tools in our MCP server.
Scoping tools to what's needed by the agent doesn't just save context window, it also reduces latency. So that's great that you did that, Apoorva.
Thank you. So finally, we are just going to create a React agent using LangGraph primitives. That's what I'm doing here. So I'm going to give it access to the shortlisted tools and a pretty detailed system prompt for what to look for during the inventory sweep.
Let's see what happens when the shop owner gets an alert.
Let's do it. So we have an alert waiting for us here. So the shop owner can come in, click into the alert in the web or mobile app. So let's click into that. And they can see what's running low. So in this case, it's a packaging component. So the alert shows you how many finished products this is going to affect and how many days before the shop runs out of this product. The agent also gives the owner a recommendation for what supplier to reorder this component from. And at this point, the shop owner really has two options. One, either take the recommendation, or they can explore further options with the agent.
And I also like that in this case, you have another human in the loop. Financial transactions are exactly where you'd want one, right?
Now, normally I would agree with you, but it's been a day. So I wouldn't hate it if this agent ordered me 1,000 bags of coffee right now. But anyway, so say I come in here, look at this recommendation. It tells me this supplier will ship valve bags to me in 8 days, but I'm just a paranoid shop owner. So I'm going to be like, no, if I'm running out of 10 days, then I need it sooner. So I can come here and say something like, is there a faster supplier? OK, the thing to notice here is that the agent isn't making any additional MCP calls. And why? It's because it already has this information from the most recent sweep that we did. And that's because we were persisting session history using our short-term memory check pointer integration with LangGraph.
That's a great point to highlight, because we've really built a robust integration with LangGraph over time. We started with our vector store, and it's only grown from there. Now you can use Voyage embeddings, a natural language to query toolkit, and a range of retrieval techniques, as well as MongoDB itself as a backend for both short and long-term memory for any agent that you build on LangGraph.
That's right. OK, so let's close this thing out, right? Let's ask the agent to place an order for that faster vendor. So let's say, let's do Harbor Line. What's it doing? OK, there we go. The agent places a purchase order. Once again, writes a record to the purchase orders collection, once again, using that insert many tool in our MCP server. And that's really all I had for you today. That's the Atlas managed MCP server in action for you.
We hope this gave you a sense of what's possible with the new MongoDB managed MCP server, from AI tools that you use every day to agents that you embed in your own products. Thank you so much, Apoorva.
Thanks, everyone.
Before I leave the stage, I want to take a moment to reflect on what we went over today. First, the MongoDB Atlas managed MCP server is now generally available as of today. The second is it is available in all the frontier marketplaces such as Claude, ChatGPT, and more. And the biggest thing that I want to highlight is that now the MCP server is available as an Atlas hosted service. It is both easy to install and easy to get started with. I can't wait to hear your feedback after you've had a chance to try it out. And as excited as I've been to show you how MCP server helps you build faster, that won't matter if your search and retrieval doesn't meet the highest bar for accuracy. And that's what Voyage AI brings to MongoDB. To tell you more, please welcome Frank and Mikiko to the stage.
All right. Well, look, earlier today, you may have heard our CTO, Jim, talk about the parallels between the cloud transformation and what's happening right now with AI. And of those parallels, architecting for this moment really resonated a lot with me. But to do that, You should bring new retrieval technologies into your AI stack, and it should be very simple to do so as well. So in this session, Mikiko and I are going to show a few things that MongoDB is providing to do just that. We'll cover the latest with our automated embedding and the Atlas embedding and re-ranking API. And we also have a new Voyage model that I'm really excited about. To give you a sneak peek, it's a bit about cost, and it's a bit about coding agents as well. But to start, we want to give you a quick refresher into the components that have the biggest impact on data retrieval in the AI applications that you're building right now.
Okay, so like many people, I'm sure you guys have started with full text search in the past, exact keyword matching. It's fast and precise. Then you've probably also tried vector search, which goes a step further by understanding users' intent, so that you can find information based on semantically similar meaning to the actual search terms. Closeness, right? So now we also have hybrid search, which combines the best of both worlds. You get the precision of keyword matching and the contextual understanding of vector search. So we provide all these capabilities out of the box. They're neatly integrated into our platform, and they're available via our managed service Atlas and also our on-premise enterprise offerings. So the search results you get are only as good as embeddings behind them. I'm sure you've observed this yourself. Better embeddings typically means more accurate, more relevant results. So when paired with a re-ranker, your search results are reordered to further improve accuracy and relevance. It's another tool in your toolkit.
And that toolkit, and a lot of those tools, part of what Voyage AI does is it brings some of those to MongoDB. Now, in particular, Voyage gives you industry-leading models that improve retrieval accuracy while also lowering the cost of getting into production. We have general-purpose text embedding models, like Voyage 4, that convert pure text into embeddings. We also have Voyage Multimodal 3.5, which can vectorize interleaved text and images while still maintaining very high retrieval accuracy. Re-rank 2.5, our re-ranker, sets an industry standard with instruction following capabilities. Now our models rank at the top of Hugging Face's retrieval embedding benchmark, beating out the likes of Google, Cohere, and OpenAI. And in particular, Voyage 4 includes industry-first innovations like shared embedding spaces, so our models are compatible with one another regardless of their size. And this means higher retrieval accuracy at a lower overall cost.
So even with these technologies available now, there's still challenges that we want to solve so that your retrieval stack works with how you can actually call it. And these challenges are access, maintenance, and now agents. So let's get into more of these and take a look at what we're announcing today. So the first challenge we wanted to solve was around access, which is how do we give you guys best-in-class retrieval with any stack without any rewrites? So this probably sounds familiar to all of you. In the past, you've probably evaluated multiple model providers to try to find the retrieval accuracy your application needs. And doing this full time, you've probably hit around 70 to 80% with whatever model you've settled on. And then you spend all your precious engineering time patching around it instead of fixing it. And the idea is that this ceiling compounds into a stack level problem. So right now, good retrieval means running a database, a vector search layer, and a model provider all together. So 3 separate accounts, 3 sets of credentials, 3 billing cycles to manage, and I'm sure a lot of you are managing even more than that. A more subtle risk that doesn't show up until later is when you switch model providers or even model versions, this forces you to reevaluate everything and to rebuild that criteria downstream. So really what should be a config change turns into this massive project. But the good news is we do have a solution for that.
And that solution is the Atlas embedding and re-ranking API, which is generally available today. Now, with this feature, you can call Voyage models directly inside of Atlas. That means that your application can build state-of-the-art retrieval, agent memory, et cetera, all on a single platform. And if your code already calls Voyage directly, swapping to Atlas is as easy as changing a URL and an API key. The tokenization, the SDK, the model names, all of that, they stay the same. You don't have to migrate a full development stack. And instead, you'd be consolidating it into a single platform to reduce development overhead. To check it out, navigate to the Atlas UI, where it will show up under AI models.
Yeah, so the second challenge we wanted to solve was around maintenance. So how do we give you only one field to edit with no extra plumbing and no second system? So currently, $vector search takes a query today, it takes a vector today, but not a query. Now, before you can call it, your application has to construct that vector itself. So you have an embedding step that lives inside your code, not your database. The embedding step usually turns into a whole pipeline. Call an embedding API, store the vector someplace. You have to keep that store synchronized with your operational database. So agents make this synchronization worse, not better. They're constantly querying retrieval with no predictable batch cadence. And so a pipeline built around batch embedding can't survive your typical agent's call volume. So switching vendors is one migration risk. The Atlas embeddings and native re-ranking API, we just solved that one. But a second migration risk survives even after that fix, which is swapping the model underneath your own setup. So you need to update the code, rerun the full data set through an external API, move the vector store over, and regression test the result. At least I hope you guys are doing that. So a simple model upgrade becomes an infrastructure project because today it is one, especially if you're doing it right.
So to solve a lot of the things that Mikiko just talked about, we created Atlas Automated Embedding. And this reduces migration risk and also makes maintenance much, much easier. It allows you to remove the complexity of having to synchronize the embeddings on your own. You just specify a set of documents that you want your application or your agent to be able to semantically search over, and MongoDB will handle the rest automatically for you. And on the other hand, $vector search now allows you to perform embedding-based search by using natural language directly inside of a MongoDB pipeline. Now, in both cases, Atlas will call Voyage AI for you, so you don't have to. And this greatly simplifies the development process and allows you to build and iterate on your applications at a faster and faster rate. This also means that switching models is really as easy as a field edit rather than a full-blown migration. You just have to change the model name, and Atlas will manage the reindexing, and evaluating a new model really becomes more of a config decision instead of an infrastructure project. Now, automated embedding runs across 5 driver languages, our 5 core driver languages, and also plugs into many agent frameworks such as LangGraph and CrewAI. And as a developer, this allows you to build your AI applications on top of MongoDB, regardless of programming language, development stack, or the agent framework that you're using.
Okay, so we've got 2 features to show you guys. With the embedding and re-ranking API, you still call them all yourself. With automated embeddings, Atlas calls it for you. So Frank is going to go ahead and share his screen. And I'm going to also unlock said screen. Okay, so what I ask is you watch and see where the embed call lives. That's ideally the only thing that really changes. Okay, so let's talk through the embedding and re-ranking API. So right now what you're seeing is the Atlas UI, and under a section called AI models, you just create a key. So we're calling ours something random because guess what? That's not the real key that we're going to use since we just showed it to you guys on the screen. We have a different one banked in. But it's super easy. You don't need a separate Voyage account or a second dashboard. You can access it in the same UI. Okay, so this is the Voyage Quick Start. You can also find it in our Voyage docs. But it's untouched, and right now it's running against a voyageai.com key. So that's our baseline, same code. It's just going to be a one-line difference, which is the API key. So Frank's going to scroll down. A lot of that code is like setting up an index, like doing the embedding, blah, blah, blah. But what you should see, or where he'll land on, is side by side, you see the same ranking, same re-ranker scores, ideally. The only thing that's changed is actually the endpoint. So now it's pointing to ai.mongodb.com instead of api.voyageai.com. voyageai.com. So usually moving your embedding calls usually means like a new auth pattern, different rate limits, like rewritten batching. So we have none of that here. So that's feature one, the embedding and re-ranking API. You still embed and re-rank yourself. Atlas is just where they go. And I know, it was embarrassingly short. Like, that's how cool it is. So short, like 4 blocks of code. Okay, so feature 2 is automate embeddings, and this is also going to be embarrassingly short. So it takes the embedding step out of your code entirely. So there's no Voyage import, no client, nothing calling embed. The same sample 8 documents we just used, we're presenting to you again, so you can see that the data isn't the thing that's actually changed. And we're just changing one field on index. So we're setting type equal to auto embed. And what will happen is Atlas will use the same model on the documents and on the query, so they always match up. Now, if you're to do this yourself, you'd have to wire up 2 separate embedding calls, and then you have to like sync it and make sure you get that right. And so while that was building, Atlas was generating the embeddings for those documents server-side and storing them itself. So you'd see like pending, building, ready. The index definition really only needed 4 things: type, modality, path, and model. In terms of dimensions, similarity function, quantization, you could use defaults for those. You're not like tuning vector parameters just to get started. And hopefully you're also not running a sync job anymore. So normally this is like a real piece of like infrastructure. It's something that you have to watch for changes. You have to re-embed the ones that have moved, retry the failures, and backfill when you change models. And until it catches up, your index is like quietly wrong. So here, a document changes and Atlas re-embeds it. Like there's no pipeline on your side to keep in step. Like that's the whole query. So no embedding client, no embed call, no vector, just the question in plain English that was passed. And Atlas embedded it with the same model used on insert. And it's not just keyword matching. So how is coffee made comes back with espresso, and they barely share a word besides Sabrina Carpenter. No, I'm kidding. Sorry, bad joke. It's the afternoon. Okay, so now what you should see is what's actually in the documents, ID and text. So there's no additional vector field that you had set up. Those embeddings live in Atlas managed storage, not in your data. You didn't write them, and you're not maintaining them. And that's automated embedding in a nutshell. So rule of thumb is when you're thinking about whether to use API or automate embeddings, because the names sound very familiar. So number one, if you're doing your own chunking or classification, or you're working with data that isn't in Atlas, use the API. Secondly, use automated embeddings when you want to search documents that are already in MongoDB. And if you guys were using these features as part of the hackathon project, that would have been a very huge unlock. Okay, so now the last challenge we want to solve is around like the coding agent use case. So how do we give you cost quality at agentic workload scale? So managed embedding with Atlas automated embeddings covers where vectors come from, but retrieval quality is a separate question and depends entirely on which model does the retrieving. So why are grep and current benchmark ranked embedding models insufficient for achieving this cost quality at agentic workload scale? Here are a couple reasons, right? Okay, so first, most coding agents still retrieve context with grep, and that is totally fine at small scale. But past a few 100,000 lines, like a production repo, it breaks down. So the first issue is that it can't rank what's relevant. The second is that it misses synonyms. So for example, you call something a session in your code and ask about auth, and grep won't make that connection for you. And it can't retrieve across files by concept at all. And so the agent grabs the wrong file and burns tokens correcting the course. Hashtag token maxing. Okay, so secondly, coding agents query in a loop. Many of you might have heard the term loop engineering, which many retrieval systems currently in production can't handle. So as the human smarty guiding a coding copilot, you'd probably fire off a handful of context lookups per session. An agent working autonomously will repeat that dozens or hundreds of times per task, running the whole loop itself of explore, pull files, edit, test, iterate. So grep's mistakes will multiply across every call, and at that volume, retrieval becomes like a real bottleneck. And lastly, once you're past grep and picking a model off of a leaderboard, static code benchmarks don't measure what agentic retrieval actually needs and does. So current code search benchmarks test single query lookup against a static corpus, not the multi-file iterative retrieval that an agent actually performs against a live repo. So a model can top that leaderboard and just still fall apart the moment it drives an agent because the benchmark never tested for what agents actually will do.
So Voyage Code 3 has been a really popular embedding model of ours. And in fact, a lot of coding assistants are built on top of it. But we're starting to see more and more of these tools act autonomously now. And that really changes what's required of retrieval. And that is exactly what we designed Voyage Code 4 to solve. We trained Code 4 specifically to reduce cost for coding agents at scale and to find the right files in a repository in a genuinely semantic way. So instead of telling an agent which file or which bug to fix, you can tell it to find everywhere that your code base mishandles empty arrays, and it'll be able to do it more accurately, more often, and at a lower cost. And that really opens up agentic coding to folks who aren't deep in the code base themselves. What you can do is you can now fix bugs in a code base just by giving it an overall bug report. And Voyage Code 4, it also solves a lot of the problems that Mikiko mentioned earlier. The ranking problem, the volume problem as your code base grows bigger, and also that gap in the benchmarks. But don't take my word for it. Let's show you what this actually looks like in an actual coding agent. We'll have two terminals. It'll be the same task, the same prompt. And what Mikiko is going to show you is a side-by-side comparison of Claude code, both with and without retrieval, using Voyage Code 4. So the repo that we're going to apply the coding agent to is Orca. Some folks might have heard of it. It is a development environment, an agentic development environment, for running a fleet of parallel agents across desktop, mobile, and VPS. And Mikiko and I, we picked this repo because it's fairly popular, but also a lot of the models, it hasn't seen Orca in training. And as a bonus, it's really the kind of environment that agents doing computer use work now are actually running into. So without further ado, let's go kick off the agents.
Oh my God, you can't see that. Sorry. Let me zoom in on there for you folks. Even more. Enhance, enhance, enhance. OK, fantastic. There we go.
So this will take about 2 minutes using Haiku 4.5 as the underlying language model. And we're using Haiku instead of Opus or Fable because those tend to take a little bit longer. So while that's running, we want to share a quick description of what you're actually seeing on the screen. So the one terminal window at the top is running vanilla Claude code. And when the agent, that is Claude code, it searches the repository for the right file, it uses pure grep, which is effectively keyword matching against the contents of the repository. Now what you see on the bottom extends the agent by connecting the MongoDB MCP server, which is able to leverage both Voyage Code 4 as well as vector search. And what this does is it allows the enhanced agent to use both grep in addition to embedding-based search over the whole code base. Now both terminal windows are using the exact same repository, and that's Orca, as I mentioned, as well as the exact same prompt. We asked Claude Code how agents running within Orca could be sandboxed, in addition to how one agent might break out. And in both instances, we're asking Claude Code to audit the files that need to be changed. The prompt itself is distilled from a real GitHub issue that we encountered for each repository. And there will be things like the perceived severity of the issue, along with a list of files that need to be changed, All of that will get written to an output audit.md file so that we're able to check the contents for correctness. All right. So with these runs, I think just about finishing up, we can see the final results. And you can see that the version on the bottom, which is enhanced with vector search and Voyage Code 4, you can see it's already finished faster, and it's already finished with fewer output tokens. Cost and speed, both of these factors are becoming more and more important today in our cost-conscious world, especially as we move away from things like token maxing and more towards efficiency. Now, time and cost are two important factors, but one thing we weren't able to show you here is how agents are actually able to solve more challenging bugs, more challenging issues, and how they're able to do it more consistently by actually leveraging Voyage Code 4. And I really encourage everyone here to please keep your eyes peeled for more content around this. So as we wait for these two coding agents to finish up, hopefully they do soon, especially the one at the top, I want to give one quick summary of what actually happened here. Both of these agents, it actually looks like it finished up just right now. Both of these agents ran on the exact same prompt, on the exact same repository, pulled from a real GitHub issue. The only difference is that instead of fixing the issue directly, we ask it to give an audit.md file. And you can see the side-by-side comparison here that Mikiko is showing you right now. On Orca, on this real issue, the enhanced version was cheaper, faster, and better overall. So let me summarize now. Voyage Code 4 is designed for the work that you as builders, as developers, are doing right now. It's optimized specifically for coding agents, allowing you to do more, allowing you to do it faster, and allowing you to do it at a lower cost. It's available today in the Atlas Embedding and Re-ranking API, and will be available through the automated embedding interface shortly. So you, as a builder, can use this model together with a lot of the awesome features that we talked about earlier. As a builder, figuring out which data platform that you want to use should be the absolute least of your worries. And if you get started with MongoDB, you have a core set of integrated tools right at your fingertips. The Atlas Embedding and Re-ranking API provides access to the best embeddings and re-ranking models directly inside of Atlas. Automated embedding takes it one step further by automating the process of synchronizing your embeddings with your data. And Voyage Code 4 makes your coding agents faster, more accurate, and cheaper, all while making the coding agents that you build more accessible for everyone, not just software engineers. And today, all three of these features are now generally available inside of MongoDB Atlas. Mikiko and I, that's all that we have for you today. Thank you for joining us. We're excited to see what you come up with. Get out there, start building, and we look forward to seeing you at the after party.